My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family, I'm cloud hired.
I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired.
Because of Go Cloud Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the GloCloud team.
Welcome, everyone. Today we are here to talk about AWS VPC security. Secure your VPC or get hacked. And while we talk about AWS VPC security, most of what we're talking about is applicable to Google's on Google's cloud as well as the Microsoft Azure cloud. So that's what we're going to talk about today. So what we'll talk about are the kind of things that you would typically want to do in security in a private environment. Then I'm going to do a refresher of the AWS VPC components and what these components actually are. And then Mark and I are going to talk about how you can secure the components with some of the cloud native tools and other things that you would want to do on a more enterprisey or more large scale security basis, because cloud security is absolutely essential. So that's what we're going to talk about today. And I love cloud security and I love enterprise security. And I've been doing the security architect thing for decades now. And for me, it's just fun. So that's what we're going to talk about today. Before we begin, let me tell people about a few things. We have a webinar on Thursday on how to become a cloud architect. On this webinar, we will discuss what is a cloud architect, what does a cloud architect do, the skills you need to become a cloud architect, and what it takes to actually get hired. It's completely free. Join us on this free webinar. We also have a free ebook that we wrote on how to, all the skills you need to become a cloud architect as well. And we've got free ebooks for AI architect, enterprise architect, and they're all free in the description of this video. So sign up for both of those. We have a couple more discussions coming on every day this week and next week. Next week, I've got a legend from networking coming. His name is Russ White. We've got lots of other executives and other architects that are out there coming. So join us for lots and lots and lots of fun. My name is Mike Gibbs. I'm the CEO of Go Cloud Careers. For those of you that don't know me, I've been an IT architect now for a little over 25 years. I'm one of the first Cisco certified internet experts of the world. I've got about 25 years of network architecture experience. I was a lead enterprise architect. Actually, for years, I was a chief architect for an entire industry vertical. So my whole life has been about networking and network architectures and designing the clouds that a lot of the cloud providers that even exist today. So that's my background. I'm joined here by our chief technology officer, Mark Milovanovic. And if it gets techie, we're going to just go to Mark. Mark is a CCI. He's got an incredible background as both a network engineer, as a network architect. So if it gets techie, I'll just be pointing everybody to Mark because he'll go really deep with any of these things that we need to do. So let me know you're awake. Let me know you're alert. Let me know you're oriented, and give me a hashtag AWS VPC security so that I know you're there. And then we'll begin the content.
I'm trying to remember now. Did we mention tomorrow's Q&A for everybody?
I don't think so.
All right. Well, that's a weekly little show that we might have put together in answering career questions. career questions about pretty much anything career related. Doesn't matter if you want to be a cloud architect, if you're being engineering role, project management, these different things. We love doing those type of sessions because guess what? We didn't have the type of mentorship that we provide there for everybody once a week on YouTube to be able to ask you questions. So feel free to join us tomorrow. It's going to start around 2 p.m. Eastern Standard Time, and then we'll answer your questions. And aside from that, Mike, I'm seeing slowly some AWS VPC security hashtags coming in. So definitely people are awake and ready for the content. And everybody also, just a little reminder, as we have these discussions, because these are general like discussions between me, Mike, and the rest of the team if they're there, but it doesn't mean that you can't ask questions. Just try to keep them somewhat within the scope of things. Just because me and Mike, we don't genuinely remember I'm guessing, what is it now, 200 different services that AWS has, and then, good gosh, all the different ones GPC and Microsoft have. But we'll do our very best to answer your questions as in scope as we can for everybody.
Yeah, well, Mark, there's a difference between a catalog being a catalog of a vendor services and being able to walk into your client's organization, find out their business goals, pain points, and challenges, design a solution that optimizes their people, processes, and technologies, and make that business better. Then there is remembering the name of every single thing out there. That's why even physicians get a physician's desk reference so they can look up what type of drug. Okay, I need a MOI inhibitor for my psychiatric patient. Here's my choices, as opposed to trying to remember them. They just know what family, or I need a statin for my patient's cholesterol. Here's my options. They all work this way, for example. So we're going to do the same thing. So the first thing we're going to talk about and we want to do is we want to define the VPC. And everybody's got their own perspective of it. So I'm going to tell you my perspective of the VPC. Mark worked in a world called network function virtualization in the past, where you have these software-defined networks, and inside of them you have virtual routers and you have virtual switches and you've got virtual VLANs and all kinds of things, but it's all in software, and it's software that's replicating a standard network. Guess what? That is your AWS VPC. That is your Azure VNet, your Google VPC. It is a private data center for you that is carved out in software in the cloud. And being a private data center, it's going to need the equivalent of routing. It's going to need the equivalent of switching. It's going to need IP addresses for things to communicate, and it's going to need all of the networking components. So guess what? Your VPC is your networking components. So what I'm going to do first is I'm going to go through many of the elements of the AWS VPC with you. And then after that, we're going to talk about how we tie these elements together that are from AWS, for example. And what are those other things that we're going to want to do typically in enterprise security that we're not going to be able to get to from the cloud provider? What are those industry solutions we need to use in a world where 89% of all businesses are multi-cloud and 98% of enterprises are multi-cloud? And what is it maybe about these enterprise-grade features and functionalities of things that may offer much better protection than the cloud-native tools? So why wouldn't we use them too? So that's what this discussion is. So the first thing I want to talk about is I want to go over the components of the VPC. The first thing is all VPCs have the equivalent of a virtual router. A router is a device, software or hardware, it doesn't matter, that will get your traffic from one subnet to another. That's what routers do, is they connect to similar networks and routers. So what you may actually see is you're going to see a routing table in your AWS VPC, and it's going to look something like this. And what you're going to see is you're going to see to get to the destination of subnet of 172.16.1.0, that's directly connected to me. It's already here. But to get to this supernet 192.168.0.0, go out the interface PCX 123.4.5.6. But you know what? Router, if we want to get to the most specific path, and we're only looking for the 192.168.1.0 subnet, not the aggregate route of 192.168.0.0, choose this interface PCX 654.321. And you'll notice there's this 0.0.0.0. That's what's called the default route. And you'll see this in the network. You'll see this in the data center. And that's a route that says, if you don't know where to go, go somewhere. And typically what you'll see in an enterprise world is you're going to see a routing table for the entire enterprise, and it can have 10,000 routes inside of it or more for the entire enterprise. And then you're going to see one route that's going to be 0.0.0.0 that's going to tell the PCs and the devices, if you don't know where to go out to the internet. And that's typically what that default route means. If you're not there or you don't know where to go to the internet. So what's going to happen at some point soon is Mark and I, after we go through the main components of the VPC, we're going to actually talk about what you can do at each one of these levels. So the next thing is we have a routing table. Now, when it comes to building a routing table on our routers, we have two ways that we can do it. One way is we can go to every single router manually and tell each router how to go. So imagine 10,000 different routers. You'd have some person SSHing or secure shelling to 10,000 different routers and manually entering at least 10,000 statements on all 10,000 routers, how to reach here, go there. Problem with that is, and here's the major problem, then you're going to get a cable cut and none of the routers know where to resend their traffic because it doesn't exist. How many of you are old enough to remember driving with map books, where when you wanted to go to a destination, you had a map and you wrote down, okay, drive on I-95 for 321 miles, get off exit 127, make a left on this Route 26, make a right, go here. And you had 18 steps, and then poof, one of them was blocked because there was a flood or a downed tree or the police blocked off a road and you didn't know how to get there. Well, at least that was me. I was getting lost all the time. So I was really excited when the world came out with GPSs. When it was first $5,000, I was like, I'm so lost, it's probably worth it. And now the GPS is ubiquitous on your phone. Well, what if I told you we could do that same thing on the network, that we can build these routing tables dynamically? And Mark and I will talk more about that when we get to routing security. But I want to tell you two things. One is if you don't have a route, you can't reach anything. Okay, so it's kind of like, let's imagine that you had a house in the middle of the ocean. And if the only route was a helicopter or a boat, and you didn't have a helicopter or a boat, and it was 300 kilometers offshore, you basically couldn't reach that. You couldn't swim the 300 kilometers in most cases. So you'd be isolated and protected, and the same thing with routing. And what you'll see is in our organizations, we're going to have two different kinds of routing that go on. In our private clouds, like our Nutanix clouds, our OpenStack clouds, or VMware clouds at our data centers, we're going to have what's called an interior gateway protocol, which is used in our internal networks. And if this is the cloud provider, they will have their interior gateway protocol running on their external internal network. And then we have an exterior gateway protocol called BGP that we use to connect to similar entities. So in this case, this system over here could be one internet service provider connecting to another internet service provider. It could be your company connecting to a cloud provider. It could be your company connecting to an internet service provider. Here's the good news. It's the same BGP that we've used for the last 30 years in all clouds, all internet service providers, and all business. So if you know BGP, this will help you. If you don't know BGP, there is an 7 or 8 hour BGP workshop that Mark and I have recently done. It has all kinds of things for you to see. Go look at it. It'll help you in your career. Tyrone, pop a link to our last BGP workshop. Now, if we understand some other components in the cloud, we have something called an internet gateway. Here's what an internet gateway is, everyone. It's a router that's connected to the internet. Get rid of all the marketing fluff. Most times, routers are called gateways. So if it connects to the internet, it is an internet gateway. If you connect some little device that makes, we're not in VPC anymore right now, but if you've got, say, S3 or object storage in a cloud provider, and there's some device that makes it look and feel like file storage that connects you, and then back end it connects to object storage, it's a storage gateway. A gateway takes you from one system to the other. That's it. An internet gateway gets you to the internet. Now, we'll talk about the concept of an egress-only internet gateway. And here's what this is. It is a device that takes your traffic outside to the internet, and it allows you to return traffic back, but it doesn't allow external people coming in. What is that really? It's an internet router with an attached firewall that says you can't come back. That's all it is. Egress-only internet gateways are IPv6 internet routers that connect to the traffic for egress only. Now, we can also have something called a virtual private gateway, and that's basically a gateway, meaning a router, that we can potentially use to connect, say, on-premise to the cloud provider. There's a couple of kinds of gateways which we could use, whether it be a transit gateway, which has got its use cases, or a direct connect gateway. They're basically just connecting to a router, which enables us to connect to other stuff. So this is just a brief refresher of what these technologies are, so then we can talk about locking it down. Now, on the cloud, we have the concept of a NAT instance. Now, a NAT instance is an AWS-specific virtual machine that translates private addresses into public addresses. It is a Linux virtual machine that translates private addresses into public addresses. So, what you could do, and in most cases this would be ridiculous, but if you wanted to take your internal users and enable them to go out to the internet, and their internet traffic to come back, and you had 1,000 users with private addresses, you could use this NAT instance to translate all of your internal addresses to a single external address using something called port address translation. And then that would go out the internet gateway out to the world. Your traffic would come back. Here's the problem. The NAT instance is doing that as a Linux machine. It doesn't have any great internet security on it. So what people normally do in real businesses, they don't use a NAT instance. They use a next generation firewall that will translate their internal network addresses to a public address, and they actually get security. So a NAT instance, for the most part, is right for the trash can, unless you're going to use it from one business to connect to another business. For example, this business was using the 10.0.0.8 address space, and this business was using the 10.0.0 address space, and then the two businesses merged. So they might be using NAT to translate the 10 addresses from here into, say, a 172.16 address space. And that way they'd still be reachable until they could put IP addresses on. So that would be the use case for a NAT instance not going out to the internet. Now, of course, AWS has a NAT gateway. And what is it? It is an internet gateway with NAT built right in. Okay, you could do this. You could use this. Or you could use a next generation firewall with an internet gateway and probably get better security and do many better things. So there's that option. We're going to walk through how you're going to lock this stuff down. I just wanted to go over a few things, so the basis, so we level set on what are these AWS VPC things. Now, in the AWS VPC, we have the concept of an elastic network interface. All that really is a virtual network card sitting in a virtual machine or a virtual anything. So it's just a network card. So the way a server plugs into a physical switch, and it's a physical network card on the server that plugs into a physical switch that plugs into a physical router that gets into the network. Here, what we're dealing here is just a virtual network card. So software-based network card. And of course, the AWS has the concept of an elastic IP address. It is nothing more than a public IP address. They just smack the word elastic on it because their branding people do it, and now it's a public IP address. In a normal world, for the last 30 years, you want a public IP address, you go to your internet service provider, you obtain one. You go to all the appropriate people, and you get the necessary permits for your BGP autonomous system number. Here with AWS, basically you don't do that. AWS owns the address. When you want a public IP address, you basically borrow it from them. You're renting it from them as long as you need to use it. And then when you're done, it goes away. Now, I'm not sure that I really want to give my IP addresses back that I may have for certain things out there, but that's neither here nor there. But that is what an elastic IP address is. It is a for rent IP address from AWS. Now, we will also talk about the concept of endpoints. And the reason we talk about endpoints are, in many cases, some of the cloud provider services are going to be inside of your virtual data center. They're going to be inside of your VPC. But in many cases, certain services are going to be outside your VPC in the AWS environment. And you have two choices when you want to connect to something like that. Go through the scary public internet, or go through the organization's private network. And let me show you what I mean by that. So in this particular environment, let's just say this is our VPC over here on the left side of the screen. And let's say we want to reach into this object storage bucket. We really have two options. One is we could leave our AWS PVC, go out our internet gateway to the internet, cross the entire internet, which basically has no guarantees of speed or performance, then have to go out the internet back into AWS. Now, here's the problem. This internet is incredibly scary. All kinds of hackers out here. So the best I'm going to do is use some form of encryption behind here to secure it, which is generally speaking fine. But there's no guarantee of performance across this internet. Now, by comparison, your VPC is physically sitting in the, if the server is sitting in the actual data center in Amazon. So that means it's there. Your performance is good, low latency. Now, your object storage here is going to be either in your same data center, same building, or very close. So again, it's going to be fiber optic connection. So going from here to here is going to be very low latency. Plus, this is going to ride the AWS internal network, which they can guarantee speed and performance on to a degree, whereas this is the external internet, and there's no guarantees of speed or performance. So you really would not want to go out there and use the internet when you don't have to. So that's why the cloud providers have this concept of endpoints. There's endpoints that'll get you to object storage, endpoints that'll get you to various services, and they're called VPC endpoints. There's a couple kinds. There's interface endpoints. There's gateway endpoints. Well, if you want us to do, me and Mark, a full day on the AWS VPC, let us know, and Mark and I will do a full fun webinar for a couple hours on the AWS VPC. Just let us know with a hashtag, please do an AWS VPC webinar. And Mark and I, if we get enough people, will happily do it. But today is more about security. So the endpoints give us better security, easier management. Now, the other things we want to think of in our VPC that we're talking about are basically virtual connections. So in the wide area networking world, if I needed to connect location A and location B, I'd call my service provider and I'd buy a wide area network link. Whether it was a frame relay link, an ATM link, an ISDN link in the old days. And if you remember ISDN, give me a hashtag ISDN. That I still don't know. But whatever the case may be, that's what people used to call it because it didn't work half of the time. But the point being is you had to buy a wide area link from a provider. Or you had to go across the internet, and the internet's not guaranteed, and try to get a best effort link. So on the cloud, if you're on the cloud and you need to connect to something, you can basically buy a virtual private wire from Amazon, and that's going to be a private link. No different than the virtual wires we've been using for the last 30 to 40 years switched over Someone's network. So keep that in the back of your mind. We can buy a virtual private line. What are the other kind of components that we actually talk about inside of the VPC that we should talk about? Well, we have the concept of VPC peering. And this is something Mark and I are going to talk a lot more about later, because this area is ripe for being hacked. And this area is a place where it's also going to enable you to do different things. And this is also going to be a place where security may be able to help you. So in a perfect world, let's say Mark and I are separated by 1,000 miles. The only way we can talk to each other is if we fly to each other's house, right? Or maybe we have a wire between his house and my house, and we can have a camera on both sides and have a video call each day. We could do it if in a completely secure environment. Now, I can also, let's say Mark has his network and I have my network. And let's say Mark likes to experiment on his network because he likes to do tech projects. And let's say when no one's looking, I take my CEO off hat and I put my network engineer hat on because I still love tech. And let's say I do some kind of wacky kind of experiment on my side. Now, if I've got a 10 gig link between me and Mark's systems are stealing 10 gigs of bad traffic at me at broadcast, I'm going to have a problem. And if I'm doing the same thing, it's a problem. So Mark may actually want to isolate himself from me. And that will bring us into the concept of micro-segmentation, which we're going to talk about much more. But for the meantime, let's talk about what VPC peering can do for you. So VPC peering could be one of two things. I can have two VPCs. This could be my finance VPC. And I could actually have another VPC for sales. Now, these could be to the same company. And if I keep the finance VPC separate from the sales VPC, no one from sales can read finance and no one from finance can read sales. Pretty secure, huh? Now, all of a sudden, I enable VPC peering between them. And now whatever information I allow between the sales VPC and the finance VPC can be shared among them. I get this wrong. People in sales can access everything in finance. I get it wrong. People in finance can access everything in sales. Or what if it's this? What if this is a car auto manufacturer? Like some of them make sports cars, for example. And let's say this is a tire company. Let's say they have to buy fancy tires from Pirelli. Now I've connected an auto manufacturer to a tire company. Maybe they've got a supply chain. But, ooh, now if the tire company gets hacked, now the auto manufacturer can get hacked. And now the auto manufacturer, if they get hacked, the tire company can get hacked. So once we start enabling communication between multiple organizations, for example, we promote the ability to build cars and get all our tires and brakes and all the coolest stuff from all the coolest places. But we also open ourselves for being hacked. So a lot of stuff is going to have to be done there. And Mark and I will start talking about those kinds of things. So lots of things we can do on the VPC peering side. Now, we also have the concept of an AWS client VPN. And I'll pretty much talk about what that is. We've got two VPNs. We can create a VPN tunnel from, let's not call it client VPN. I can create a VPN tunnel from my data center to the cloud. And I can also have my PC connect to the cloud in a VPN environment. So ultimately, when we create an IPsec tunnel, we're connecting to something called a VPN concentrator. And the AWS client VPN and these types of things are a software-based VPN concentrator. And again, we may have other solutions which we want to choose better, although there's nothing wrong with that. So what are the other components of the VPC? Well, I mentioned we have routers, things like transit gateways. They're just routers when all is said and done. We don't need to go into that right now. Now, what else do we have in our VPC? We have load balancers, right? We have load balancers that enable us to load share across devices. And we could load share across virtual firewalls. We're probably going to do that today and talk about creating high security. We could also load share across two different web servers. So we're going to have that. So how do we lock down our load? How do we lock down our load balancers? Because that's something we'll need to talk about. Now, whenever you're dealing with layer 3 routing, guess what options you typically have on a router? I have the ability to protect one subnet from talking to another subnet. I can typically do that with something called an access control list on a router. And whether you're talking about a network security group in Azure or a network ACL in AWS, it's the same ACLs that Mark and I have been playing with since 1990 something. And well, I'll admit to 1990 something. I don't know if Mark wants to completely admit that one. And again, the same kind of things that exist on ACLs and the cloud, those same best practices Mark and I will talk about will also apply. We also have the concept of host-based firewalls that we should talk about. And we also need to talk about how to access, say, web-based applications, how you may isolate them, which Mark and I are talking about. We'll talk about. And even though it's not part of your VPC, we're going to also talk to a slight degree about SIEM systems and what they do and what data loss prevention systems actually do, because that's what it's going to take to lock down your VPC. And that's what it's going to talk about. So as we go through this, I'll hold a conversation with Mark and we'll talk about different things. So the first premise of security, which most people don't think about, I always start about is the network. And since the VPC is a network, let's start about the network. I want to make it clear what happens if you don't have a route to it. And you know what? I'm actually going to draw it out for you so you can actually see it. And because if you understand this, you'll understand some of the most essential security things we can do, which cost us absolutely nothing to implement, and for the most part will increase our security and our robustness. And the first part of it is going to start with networking. So here's what I'm going to do right now. And bear with me. I'm going to build a little bit of a network over here. I'm going to put I have two routers over here. So router. And I'm going to put another Ethernet segment on this router. And I want to show you what happens if you don't have a route to something. And here's the host. Here's the host over here. And here we've got a server. And the server's IP address is 192.168.1.5/24. And the router's IP address, let me just, over here, is going to be 192.168.1.1/24. So you can see this server and the router are on the same subnet. Now let's say this link over here is, let's say right over here, this is the 10.0.0/24 subnet. Bear with me for the host. Oh, no wonder something wrong. So let's say the host is .5, which means the router is going to be .1. Let's put them on the same subnet. Now, while we're at it for this WAN link, we use some very goofy IP addresses, but I want to use it to show this, to prove the point. And that's why I'm using these. 172.16.1.1/30. That's for this link. And then this is for this link. So here's a traditional network. Let me move it all over because some of it's hard to see, that we've actually created. So let's say what happens right over here. Now, right now, we've plugged in all the cables on these routers, but we've not enabled the routing protocol. If we haven't enabled a routing protocol yet, what'll happen is this router will know how to reach this subnet, and it will know how to reach this subnet. This router will know how to reach this subnet because it's directly connected, and it will know how to reach the subnet on its wide area networking link. But this router will not have any idea how to reach the subnet. So what'll happen is, let's say the host wants to go to a web page that's 192.168.1.5. So they put that IP address in the browser. Now, the first thing what's going to have to do, the PC is going to look in its routing table and it's going to say, do I have a route to get there? Now, in this case, the PC has something called the default gateway. So the PC, so it'll say ARP, who has the MAC address of 192.168.1.1. And often what I'll have, typically speaking, or the router will proxy ARP and respond. Now the packet, let's assume it makes it to this router. This router will look in its routing table and it will say, do I have a route to 192.168.1.0/24? And if it's not, the packet gets discarded. So the host can never reach the actual server because there's no route in the routing table. So what are the implications of this? And why does this give Mark and I so much activity? If you don't want something to be reachable and you don't have a route to it, you can't reach it. So, Mark, we use BGP to connect to the cloud provider. Mark, we use BGP when we peer with various VPCs. Is there anything I can do on the BGP side to determine who can actually speak to whom and who's allowed to receive which routes?
Well, the beauty with BGP is that it's a manual implementation and configuration, which means basically, unless you configure that somebody can talk to you, it's not going to happen. As a matter of fact, there's a very good demonstration in the BGP bootcamp that we did not too long ago, where we're actually showing up that if you don't explicitly configure BGP to communicate with a neighbor, what happens is you never go through the actual TCP session establishment, which means by default, the sockets don't get bound. And for anyone who doesn't understand, that basically means we're taking your IP address, the BGP port 179, assuming you're the server and not the client in that sense, and we're binding them together. And what you'll notice is that the message will actually come into the router if you're doing kind of like a debug, and it will tell you that the port is not open, I'm not listening, and will simply discard it. And then you're going through that whole spiel again of idle and, I'm not forgetting, I'm blanking on the other one, idle, active, and you're trying to continually establish the sessions. But number one really comes in that you have to explicitly configure BGP to want to talk to somebody. So that's number one. Then the other thing that we can do, and this is really it's not the best way of doing it, but again, considering that BGP by design is relatively insecure, because back in the day, nobody was thinking about people going crazy on you and trying to do all kinds of funky things to your network. But you can use a TCP option by actually including a password that gets hashed. But what many people don't remember is that this password is actually part of the TCP session. So it has to be going through those sessions, be able to just get the TCP session up. So that's one way you can do it, having different passwords on it to prevent the different neighbors of being actually able just to establish the session. So that's pretty much key. And then when we're talking about who can talk to who, making sure it's configured appropriately. And then number two, of course, we're going with the password that you can add as a TCP options. Now, there's other things, of course. Yeah, Team 179, right? If nobody knows, port TCP 179 is specifically for BGP. When you're going to be the server on the other end, meaning the initiator of the actual connection. There's other things, of course, that you can do as well, but they're more on what happens after you've already established a kind of like a neighborship, a communication channel with the other router. So that would depend there if we want to allow it. For some people, I don't necessarily consider this, how would I say, well, I guess we can consider it a security. It's basically, a lot of people just call it TTL security. It's actually, if I remember correctly, I believe it was called generalized, right? Yeah, generalized TTL security mechanism.
Yeah,
it's a little bit different than the original one that you have in a lot of the different routers, where they call it a directly connected check, and then you disable it, and your TTL is the same. Here, what you're actually doing is you specifically defining how many hops away a BGP speaker can be, and how many hops away you will accept it from. The nice thing about that is that it doesn't allow anyone to actually pretend to be a man in the middle, because you're locking down the mechanism of how far away a neighbor can be. So a lot of people think that BGP neighbors, especially eBGP neighbors, external ones, can only be a directly connected neighbor. It's not true. So you have this mechanism in place where you can actually define how many hops, so we call them how many routers away the BGP neighbor can be, and then how we will traverse through the different sessions. So this could be something very useful. I always recommend everybody make sure that you're specifically configuring who you want to talk to. Make sure that you lock down the TCP session through a password. Have different passwords, of course, for different neighbors, and then use the TTL security mechanism in place to make sure that you can't have a man-in-the-middle attack. So these are what we call, generally speaking, type of session-based attacks that we're trying to mitigate when it comes to BGP.
Thanks for that, Mark. And what I'm going to do now is I'm going to actually show two things. So one of the reasons we use BGP is it scales, but we also use BGP for, they used to call it their nerd knobs of the tunability. And here's what I mean. If we were using a normal routing protocol and we connected, say, this VPC and this VPC, they're going to share each other's routes. But let's say I've got this subnet that I don't want anybody to be reaching, and it's the 10.0.0.0 sub .0/24 subnet. But I've got servers and workers on all these 172.16.0.0 subnets that I want the users from VPC B or company B or department B to be able to speak to. I just don't want them to be able to reach this. So when we establish this BGP connection, we tell BGP by advertise these routes. So if we tell BGP to advertise only the 172.16.0.0/16 routes, then you've got a user here that wants to be able to reach a 10.0.0.x route, and they can't because it's not there. Now, of course, that doesn't preclude someone coming from VPC B to create a static route to the other VPC. But even if they were to create a static route on VPC back to VPC B back to the first VPC, this VPC wouldn't have a route back to that, to potentially those subnets either. So we might actually, depending upon how we did the routing, we'd be in control. So with BGP, we're going to determine which routes we take in or choose to take in. Meaning, if we're expecting to take in the 172.16 subnet here, that's all we're going to take in. We're not going to allow someone to advertise a 172.17.0.0/16, which is ours, back into us. We're only going to allow what we're supposed to in. And as Mark mentioned, we're going to make sure we authenticate the peers. We know how far away the peers are, and we're filtering out the routes in. So that keeps people from injecting bad traffic and bad routes into our system. So I want you to think about this while we're talking about VPCs and we're talking about routing. So in my data center, I have a lot of security features I just don't have in the cloud. On my data center, I have complete control over the network. And what does that mean? It means that I can say Mark's traffic goes over Cindy's traffic, who goes over somebody else's traffic. And I might need to do that. Voice and video go first, mission critical application traffic goes second. And maybe I have one queue that says drop any, maybe I have one queue that's a low priority queue. And why is that? What happens if I get a worm or a virus on one of my machines and it starts generating traffic? Do I want my mission critical traffic and my voice and video traffic to go through, or do I want worm traffic? So in our network, I can prioritize. I can't do that. In my network, I can micro segment. I can create all these little layer 2 segments. I can make sure if you plug into the wrong port, the port gets shut down. I can put 2 servers in the same subnet, and they won't even be able to talk to each other, even without an access list with things like a private VLAN. So I can have a private VLAN, then I can have a layer 2 access list, and I can have QoS, and then I can still have a layer 3 access list in my data center. I can't do most of that here. I'm reserved to a layer 3 access list. So what you often find is what businesses are doing is they're micro segmenting their clouds. So they're making a VPC for finance, and they're making another VPC for sales, and they're writing another VPC for dev, and they have all these VPCs. And they create hundreds. You may find some enterprises that I'll have 1,000 VPCs, which gets real complicated from a VPC peering. But let's say this is not finance. Let's say this is product, and which of course I have prod UCT. Spelling live is never a good thing. And let's say this is customer support. Let's say this is tech support.
Are you meaning to share your screen, Mike?
Yes, I am. Okay. Thank you. Tech support. So here what we've done in order to make the network tech support. So here what we've done is we took our AWS VPC and we chopped it up to 6 VPCs. Now, a lot of high security environments do this. Now, what's the trade? Some cloud providers charge you to route in between VPCs. Now, in your data center, you don't have to pay to route between VLANs, but in the cloud, you often have to pay to route between VPCs. But if I've got a different VPC and all my VPCs are separated, can I run firewalls in between these departments? I sure can. Can I run route filtering between these departments? I sure can. Can I run access control lists between these organizations? Sure. So now in this case, if I need really good security, I have a thought of, do I micro segment my VPCs and maybe use 50 of them, 100 of them, or 1,000 of them and pay for the routing in between VPCs, which I can do? Or do I deal, and that's to get to the level of security I had in my data center, that's still not going to get me as good as data center security, but it's going to get me close. Or do I deal with just standards-based stuff? I don't know. It's up to you. What is the cost of confidentiality, availability, integrity of your data to the business? Every business is different, and that's why architecture is never ahead of time. We always have to figure out what problems are we going to solve for that unique customer. So I kind of hope that shows the BGP and the networking side. So now let's talk about another thing that we can do, since we basically talked about the first one. Now we talked about basically route filtering and segmenting. So another thing we can do is be sure that we definitely segment things like production from development and testing. You definitely don't want that stuff to be able to talk to each other in general things. Another thing we do, let's talk about the IP addresses. Don't put public IP addresses on things that you don't want reachable from the internet. If they're in a private subnet, they're going to be harder to hack from the internet unless you get onto their network somehow. So private subnets for your information. Now, if something's in a subnet, Mark, do we have any way to protect subnets on routers? One subnet to another subnet that can determine who can speak with whom, for example?
We do. Number one, do your research when you're going to have a vendor equipment. Some vendors are sneaky and they provide a routing by default between subnets. But that joke aside, we generally would be using, there's a few mechanisms, but let's go with the easier one because the other one we can kind of talk a little bit more about when we talk about transit gateways. But generally speaking, what you would try to do is use access control lists.
Yeah.
And then you would define, and this is one of those funky kind of things, right? When you do access control lists, you want to define your least specific allow instances first. Because a lot of people, what they do is they start off with being very specific, and then by the time they get down in their list, like 100 lists, they remember, hey, you know what? There's actually a deny all statement at the end, and I kind of got stuck. So common issue that we all face. But you always use access control lists, and the nice thing about them, in generally speaking, most physical and virtual devices have this capability, is that you can not just match on the particular IP addresses, meaning those network addresses, but you can also tie down particular port numbers that you want to with it to add some additional granularity in regards to the services that will be allowed to traverse those different networks. But number one would be the access control list, just with the source and destination network. And then for some granular control, especially if you're trying to just kind of weed out some services which are allowed, you would use additional things such as source and destination ports. That kind of helps with that.
Okay.
And then later on, we can get a little bit more when we talk about transit gateways. This is a possibility as well with normal routers, but you can use also basically virtual routing and forwarding instances. And for those that don't know what that is, that basically means that we take the concept of VLANs, which do a form of segmentation on our bridges or our switches, and we take that same concept to our routers, where we actually create separate routing tables for every network. So now we have logical separation. But we'll talk a little bit more about that when we actually get to the transit gateways, because the transit gateway has a similar capability there to allow us some additional segmentation.
So I'm going to highlight a little bit about the access control list Mark talked about. And I'm going to talk about both two things, improper and proper technique to create these. And I'm going to show you why. And then I want to show you what it is about non-stateful things that like access lists that make you apply them in both directions versus next generation firewalls and firewalls themselves that actually can do much more and they're stateful. So what we have to understand is the ACL is a packet filter. And as Mark mentioned, it has an explicit deny any at the end. So for the most part, if we don't permit something, nothing is going to get through. So think about that. So look at this first way. And when we deal with access control lists, they're basically processed in order. So what does this mean? If we look at this ACL, and while the syntax is the same, this could be you put on a Cisco router, Juniper router, Extreme Network Switch, AWS, Azure, Google. If we create a first rule that says deny everything, the router will throw it away. The packet will never make it to the second rule that says allow your TCP port any. Now, the thing with ACLs, which Mark and I are going to teach you in a minute, is they are not stateful. And I will show you what that means in a second. But because they are not stateful, you will have to tell them on the inbound side and the outbound side, you will have to apply it. Now, this is the exact worst way to do this. Now, here's what you do instead. You allow very specifically what you want in. Allow TCP port 80 from basically any source. Allow the response from TCP port 80 to any destination. Now, we don't have any denials, and basically what's going to happen is this is just going to permit it. So why did we talk about that, and what is the difference between stateful and non-stateful? So here we will talk about that. So when I'm dealing with stateful, when I'm dealing with something is tracking where my information is actually going. I have a device, it's paying attention to something. That's what we're talking about with regards to stateful. So I'm going to show you an example of a stateful ACL, stateful firewall, stateful whatever you want it to be. And if we're dealing with an AWS security group, which is a host-based firewall, it's going to be stateful. If we're dealing with a Palo Alto firewall, or a Fortinet firewall or a Cisco firewall or a Checkpoint firewall, it's also going to be stateful. And if we use something like AWS WAF as a firewall, and we'll talk about later why you probably shouldn't in most enterprises, but if you were to do it, it's still going to be stateful. So here's what stateful is. Here we've got, in a stateful environment, we have my absolute favorite internet user. Her name is Cindy the cat over here. She loves going to the internet. And see, Cindy somehow got a hold of my heart and credit card both at the same time. And somehow Cindy gets every ridiculous thing she wants, including fresh shrimp and scallops every single day. And I try to get her at least sashimi tuna at least once a week because she loves it. So now we've got the scary, crazy internet here, and we've got a firewall, which is going to be stateful. And whether it's a security, anything, we're always talking about a stateful firewall. Now here we've got a web server, and this web server is Cindy's favorite fish and seafood.com. Now, granted, there's some typos in there, but so here's the way it would normally work. Cindy's sitting behind the firewall with her private IP address, and she's behind an enterprise-grade next-generation firewall. And believe me, I wouldn't let my cat sit behind something that isn't going to be really strong. And when Cindy goes to the Cindy's favorite fish and seafood.com, she leaves her internal network. The firewall says Cindy is going to Cindy's favorite fish and seafood.com. Now, when Cindy sends that TCP SYN, open that web connection with me, Cindy's favorite seafood and fish and seafood.com, whatever, acknowledges Cindy's SYN with an acknowledgement and then sends a SYN to me to open a connection. Now, because the response is coming from Cindy's favorite fish and seafood.com that was initiated on the inside by Cindy, and the firewall kept track that Cindy, it allows the traffic back in. And now Cindy's traffic goes back to this session, and this traffic is allowed to return. Now, what happens? An hour later, Cindy's session is torn down. Someone out here decides, it can even be Cindy's favorite fish and seafood, but hours have passed, the firewall's timed out. They try to send a connection in, and they are blocked by the firewall because they've never been allowed in on the ever. The only difference that happened here was the firewall kept state that knew where the traffic was, so it knew how it allowed us to turn down. Why am I saying this? And then I'm going to come back and talk about different firewalls and why you should consider different things for your VPC. And of course, we'll architect a DMZ for you because we have to, you know. So if we had a firewall, it's keeping track of where the traffic was. Access control lists don't keep track. So it's that state. But is it really any different than if somebody's at your front door, they're your friend, you allow them in the front door, they go in, they go out, they run to their car, and you're expecting them to come back anyway, and the door's open and they come back in? It's fine. You have state. My friend Mark came to visit me, and he came in and out of the house, and life's good. We don't have a problem here. So that is state. So let's talk about the three kinds of firewalls that we actually have in today's world. And let's talk about why, in general, to secure your VPC, if it matters, you're not going to use an AWS WAF. You're not going to use any of the other cloud native tools. So let's look at the difference between these and the way these firewalls all behave. A traditional firewall does everything that I just showed you. It's stateful in the way that it keeps track of where the data is going from. A layer 7 firewall like AWS WAF and all next generation firewalls does a really good job of not just looking at the session from a perspective of Cindy's IP address, protocol, and necessarily port number. They're going to actually look at the HTTPS application itself. So automatically, AWS WAF would be better than a traditional old school firewall from 20 years ago, as are all 100% of new firewalls. Here's the difference between an AWS WAF and an enterprise-grade next-generation firewall. In AWS WAF, here's what happens. It will block you from all kinds. It will block all traffic from coming in except for the traffic you permitted, just like all firewalls. like all modern firewalls, it'll look at layer 7 of the packet as layer 7 of the session, not just of what's going on between sender and receiver, not just layer 4 information like TCP source and destination address like it. Here's where the difference is. In, let's say, out of nowhere, you start getting traffic that looks really, really weird and wacky, etc. Really, really weird and wacky. If it's a known attack, meaning something that's happened in the past, with an AWS WAF, you can subscribe to another third-party service that says, oh, this attack has been seen. We've caught this attack before. We're even going to stop the attack. It's called signature detection. Here's what signature detection is, and I want to make it very clear. Okay, we've got a pandemic, and after we found out there's a pandemic, we're going to immunize everybody. And then after they're immunized, they won't get sick again. But did that stop anybody from getting sick in the pandemic in the first place? No, because everybody already got sick first. So when we're dealing with a next generation firewall, specifically the modern kind that have these anomaly and behavioral-based detection systems, which you'll get from Palo Alto, Cisco, Fortinet, or Checkpoint, but you won't get from a cloud provider, here's what they do. They're constantly watching the environment. They're blocking all unknown attacks. They're blocking unnecessary traffic. All of a sudden, they see an attack like WAF has seen before. They stop the attack. No big deal. Now, something's different. Now, over here, you got Hal the hacker. And Hal the hacker is really smart. Hal the hacker is really sophisticated. And Hal the hacker launches a weird attack at you. An attack that's never been seen before. You've never seen an attack like this because Hal the hacker is smart. But when your next generation firewall is starting to look at the weird traffic patterns that are coming from Hal the hacker, your firewall is now using its AI to say, I don't like this. I really don't like this. Something doesn't seem right. I'm just going to block Hal the hacker and everything that's coming in at me. So as you can see, when we go from a cloud provider's one, first, we don't have any of that intrusion detection and prevention natively. But then with the cloud provider, we can subscribe to a third-party service and get that some of that intrusion detection prevention, but it's signature-based. But if I deal with an industrial-grade firewall like that from Cisco, Palo Alto, Fortinet, or Checkpoint, when Hal the hacker launches a day zero attack at me, one that nobody's ever seen before, we may still be able to mitigate this attack. So what's the net lesson here? Use technology that works and don't limit yourself to a single cloud provider. So this is the same technology like your credit card would use. And I can tell you, if you take your credit card, if you, let's say you live in Palm Beach and you leave Palm Beach and you go to DC and spend $2,000, and then go to San Jose, California, spend $5,000, go to London the next day, spend $3,000, and then go to Dubai and stay at the Burj Al Arab, I guarantee you, unless you're used to doing it, your credit card company will shut it off. Their anomaly detection will say that's not your pattern of behavior. Now, you take our training, you're working as an enterprise architect, you've been an enterprise architect, you're now at a consulting company, and that's now your new pattern of behavior. Guess what? Your credit card company will learn. So those are our firewalls. What kind of firewalls do we have options with in the cloud? The cloud providers ones, or the many magical types of next generation firewalls. And when we design a demilitarized zone later in the session, we'll show you why you might use more than one kind of firewall. And here's the other reason we don't use the cloud providers' native firewalls when it comes to real security. 89% of all businesses are multi-cloud. 98% of enterprises are multi-cloud. And I can't have 5 different kind of firewalls that I'm trying to deal with and manage across cloud providers. I need something that I can use a good set of software that can manage them. So that's another reason. But we still get some free firewalls from our cloud providers, right? We can use the ACLs, right? And we can also place something called a security group. Now, what is a security group? In all seriousness, what is this concept of an AWS security group? Well, I'm going to show you right now. An AWS security group, strip out all the fancy marketing and branding. Is, let's say you've got a virtual machine over here. Didn't you always have the option of saying on this machine, installing a host-based firewall? And the host-based firewall would act like a firewall to protect the system from the world? Of course you did. And guess what? Here's what a security group is. It is a AWS firewall-based service. Azure has a network security group firewall-based service that acts as a little firewall. Let's pretend here is the Ethernet card. It sits between a little firewall, only allowing traffic into the virtual machine that you want. So we could put this on a load balancer. We could put this on a virtual machine. Now, in an AWS Solutions Architect Professional certification, they're going to say that if you put a security group in before your virtual machine is secure. Is that secure, everyone? Is your virtual machine secure just by putting a security group on the outside of it? Please, I beg you, don't think so. And here's the reason why. No operating system comes out of the box secured and hardened. So here's what we're going to do. And ultimately, we'll put all these pieces together for you for a DMZ, for a web application. But here's what you need to do. You need to take those virtual machines themselves. You have to remove any unnecessary service, close any unnecessary ports that are on these virtual machines. You need to patch these virtual machines, and then you need to put some anti-malware protection on this. You typically need some host-based IDS, IPS systems. You probably should put a host-based firewall on it and a security group. Okay, so why is that? Any of you ever seen those really cool Russian dolls where you got a little doll and you put it goes in another doll and it goes into another doll and it starts out this itty bitty and then the dolls get really big and you keep going and you never get to the little doll? My grandmother used to have them. Well, if you ever peeled an onion one layer at a time, it's really hard to get to that center of that onion, and I want it to be hard for my hackers to break it. So that's what we're talking about. That's the equivalent of a security group. All the cloud providers have it. That doesn't mean you shouldn't do these things. So I would like you to think about that. We are thinking about micro-segmenting. We are thinking about locking down. So where do we use our firewalls now? VPC to VPC, firewall. Between AWS and Azure, firewall. Because if AWS gets converted, if you've got half your systems in AWS and Azure gets hacked, guess what? AWS is going to get hacked through Azure unless you've locked these systems down. So there's firewalls. So a lot of this, what we talked about is all network security. So the load balancers themselves, how are they going to help? And let's talk about load balancers. And we'll talk about many other elements that are going to come to play here. But let's talk about load balancers in the context of cybersecurity, specifically load balancers in the context of a distributed denial of service attack. So let's say we're in this environment, and let's say we've got two web servers right now. Web server. And let's say each web server can handle 5,000 requests per second. And obviously we're working separate when we put these things together. And now let's say over here, we've got how the hacker again. And how the hacker infects a whole bunch of other servers out there. So these are infected servers. I'll call it IS for infected servers. So I make less spelling mistakes as we go through this. Now, how is remote controlling these servers? But let's say there's 1,000 of them. Now, he's controlling these servers. And then these servers are sending a wacky number of web requests to us. And right now we can handle 10,000 web requests per second. But these servers themselves are actually going to be sending 30,000 web requests per second. So now I can only handle 5,000, but these bad actors are now sending 30,000 requests per second. What happens? I've been DDoSed. My servers are busy dying answering these ridiculous requests. So let's talk about this. So this outside of this is going to be the public address. And all these addresses are going to be public or private behind here. Now, if I get hit with a DDoS attack and I'm on a cloud, it could be a Nutanix cloud, an OpenStack cloud, assuming you've got capacity, AWS, Azure, or Google, and we are overwhelmed. Can auto scaling, based upon what's going on, add capacity to these web servers? Yeah, it can. Now, all of a sudden, auto scaling, and guess what happens? Now I got a whole bunch of servers. Now I'm able to withstand the DDoS attack. Now, was this DDoS attack expensive to me? Scaling out to adding a lot of additional servers? Yeah, it was. But did it help me survive the attack until I can figure out how to thwart and stop the attack? Maybe it did. Maybe it did. So for argument's sake, and this is not technically part of your VPC, but I want you to think about this. Let's assume we got a large number of bad requests coming into our system. So if I wanted to open a session with Mark, I'd send, the way TCP works, pretend Mark, you're a web server right now. Mark, I'd like to open a connection with you. SYN. Mark, what were you going to respond to me?
I'm going to first send an acknowledgement and then a SYN message right back to say that I'm willing to talk to you.
And then I'm going to send an acknowledgement message, and then we have a session. Now, Mark, you're a server. You got a limited amount of memory and a limited amount of CPU resources. And I send you 50,000 SYNs real fast. And when you reply, I don't actually reply back.
Well, what's going to happen is I'm going to keep trying until my timeout reaches the maximum. And then eventually I stop the session. But that's also going to be application based. So
yes,
that's going to be a bit of a problem for me.
It could be a big problem because he's wasting all his space on these open connections. So what if when I saw some stupid TCP SYN request or a malformed web service, I just dropped it before I ever sent it to Mark in the first place? Mark, if you didn't see any of these bad requests, are you still happy?
Oh, I'm ecstatic.
So Mark's still going, well, so what is this? What do we typically can do before it even hits our firewalls? Is there a way that we can kind of replicate our web data, get our web data a little closer to our users, and drop the bad data directly there? So that's where we enter the world of content delivery networks. And I'll kind of whiteboard some of this out. It's not exactly VPC security, but here's the thing. When you create a web security architecture, you're going to want a content delivery network. Now, I'm going to make it very clear to you, a single content delivery network is a single point of failure. If you only use a single content delivery network, expect your systems to go down. And if you are an enterprise architect or a big architect and you've done something silly like architect a single point of failure in your content delivery network, your replacement will thank you for the job when they get hired. And that's why if you do an NS lookup of www.amazon.com, go do it. You're going to notice that they don't just use CloudFront. They use Fastly. They use many other content delivery networks too. Even owning their own, they wouldn't be crazy enough to use a single content delivery network, nor should you. So unless you don't have any kind of mission critical requirements. So here's what a content delivery network is going to do. And I'll kind of help you sort of figure out what these environments look like. So let's say I've got my web server here. And let's say these are internet peering points along the internet where a bunch of internet service providers have their systems. They're called point of presences. And what I do right over here is in all these locations, let's say, let's call this CDN. So in this particular environment, I connect to the content delivery network. They have a network that's typically at internet service provider peering points spread throughout the world. For example, Akamai's got 44,000 plus locations. AWS has 400 locations. Now what would happen is there's two things that can typically happen here. So let's say I've got a user here, and let's say this user is Nikolaus. So Nikolaus wants to access this system. Nikolaus is in Neopatamos, Greece. And Nikolaus tries to get to the website from this web server. Now, Nikolaus hits the local internet point of presence. It's not there, but he sent a very good request through the point of presence. It hits the content delivery network. It goes back to the web server. The web server responds. It goes through the content delivery network, and now it is cached. So now over here, the page that Nikolaus went to was great. He went and reached it. Now, 5 minutes later, Nico's got a friend called Aguilo, and Aguilo also wants to access the same web page that Nikolaus went to 5 minutes ago. So Aguilo hits this point of presence, and the information is already there, so he's been sent back because it's cached, and it's a cached hit. So now let's assume that all 10,000 people in Mike's home village in Greece, which is Neopatamos, all decide to go to the same website that day to see Cindy the cat, because everybody loves Cindy the cat. They're all going to get it only from a single answer. So this adds scalability. But now we've got Nico over here. We've got Agilo over here. But you know what? Oh, wow, there's this hacker named Apostoli. And Apostoli, oh, this guy's a bad guy. So now this guy tries to send 18,000 malformed TCP SYN connections, and that content delivery network just said, sorry, Apostoli, this is garbage you're sending to us. You're not allowed. So that's why we typically use a content delivery network. And the reason we're using these content delivery network is that it actually can not only help our web server scale and help us defeat DDoS, but also it drops stuff before it ever hits us. So far, what have we talked about? We talked about route limiting, right? We talked about route filtering. We talked about packet filtering. We talked about filtering with access control lists. We talked about filtering with ACLs. We talked about filtering with traditional firewalls, and we talked about next generation firewalls and why you might use them. So these are some things that are going on that you're going to be thinking of inside of your environment. Now, inside of our VPC, we've got firewalls, right? We've got routers, right? We've got routing, right? We've got ACLs, right? And all this stuff going back and forth, traffic going from point A to point B. Is it tracked? You better believe it, it can be tracked. So if, let's say we're in a multi-cloud environment, and AWS has given us a bunch of CloudWatch logs and CloudTrail logs. Now you've got a Nutanix data center and you're getting logs from all your routers and switches. And now you're also in Azure, like 98% of organizations, enterprises are multi-cloud. This is what your network looks like. And now you've got all these logs coming in your Azure VNet. Is AWS CloudTrail doing you any favors? Is AWS CloudWatch doing you any favors? Are you going to be able to figure out when somebody hacked into your Azure VNet, how it got into your Nutanix VPC by using any of your AWS or Azure native tools? No. And the reason you're not going to be able to is you're not going to be able to correlate all these labs coming from logs coming from different sources. You may have 100,000 servers and they all spew syslogs. Now you're going to have all your routers and switches and firewalls. You're going to get logs like crazy. So that brings us into the world of how do we deal with these logs? What are we doing? How do we deal with this? And this is not going to be another cloud native service. This is going to be an industrial service because we don't just have logs from AWS stuff and logs from Azure stuff. We potentially have 1,000 different vendors that we're dealing with and their logs too. And how do I know when Mark did something at 2 o'clock in the morning and he made a little change on a routed interface on his router, which should have made no difference, and we had a proliferation of an outage in our entire network? How do I correlate this stuff? If I've got 3 different logging systems, I don't. Or 4 or 5 or 10 logging systems. So what you're typically going to see is something called the SIEM system. And I don't know what I did here. Bear with me a second. And what these SIEM systems are going to do, which we'll obviously usually put in either in a server or they're managed for us, is let's say this is AWS. And let's say this is, and let's say this is Azure. Heck, while we're at it, instead of Nutanix, let's just make it Google. Let's use all 3. All great clouds. While we're at it, let's just, now we're going to send all these logs to a single system. We're going to aggregate these logs across our cloud providers and our data center providers. And now we're going to have everything in one place. Now, this is typically called a SIEM system. Now, SIEM systems will aggregate the logs from everything. And they will usually have some form of AI or artificial intelligence to start looking through the logs. And these can be every kind of log from who logged in and what time they logged in to what they accessed to firewall logs to IDS, IPS systems. Now, these SIEM systems will typically go out there and they will literally make it very, very clear for you the types of things that you need to do to lock down your systems. And who do you think makes these main SIEM systems that you use in every cloud? Splunk, IBM, for example. And even Splunk and IBM is probably 60% of all what's used in the entire global enterprise for these types of systems. And why are we doing this? What are we looking for? I don't just care what's in my AWS cloud. I don't just care what's in Azure. I've got a whole enterprise that I need to worry about. So that's typically why we're using these different kinds of servers. We're going to be using these enterprise grade servers. And let's talk about a couple of other security things, and then we'll actually build it out for you. And then Mark and I'll take plenty of questions. Mark and I love answering questions. So what about people stealing data from our systems? Do we need to monitor for that? Information coming that's not supposed to go? So this is also going to bring us into another type of system that we need to be integrating for our security. And that brings us into data loss prevention type solutions. And these are going to be software type packages that are going to make sure that data doesn't leave your systems the way it's supposed to. So who's typically involved in this? Well, we've got Broadcom in the form of Symantec, pretty comprehensive solution that's out there. We've got ForcePoint that does something big. We actually have McAfee. It's the old Trellix. Microsoft has a product that's typically used in a lot of places. Trend Micro has a system. Proofpoint has a system. Checkpoint has a system. Cisco has a system. Netspoke has a system. RSA, I think they're Dell now, that actually did it. Zscaler has a system. So, of course, we're going to have a lot of things that are going to be monitoring for data going outside of our environment that we don't want. So now we've got a data loss prevention system. And, of course, we have the concept of identity and access management, which is typically going to be some form of federated. But and then we'll build an architecture together, and then you guys can ask questions. So I want to talk about this IAM. So many people confuse identity and access management with security. It is a component with security. Let's talk about where people go wrong considering IAM into security. So imagine this level of security, because I can do it. In order to reach me, you have to drive 100 miles through the desert. And then in order to get to my house, surrounding my house, I have a 500-meter tall wall. Now, the wall itself is greasy and slippery to make it hard to climb. And at the top of the wall, there are razor blades everywhere. Now, at the top of the wall, I've got some snipers that I hired from the Marine Corps. They were Marine Corps snipers that are standing there protecting guard. Now, in between that wall and my house, I have a moat. And I have bought 1,000 of the most aggressive crocodiles in the world that I filled that moat with. And behind that moat, I've hired some commandos from the UK, some SAS commandos, some Delta Force commandos, some Navy SEALs, and I've hired them all to be my security. And then after that, that's when you get to knock on the door and present your ID and say, I am here. Well, who's scaling the 500-meter wall? Nobody. Who's getting past the snipers? Nobody. Who's going to go through that moat and not get eaten by those 2,000 aggressive crocodiles? Probably nobody. And if anybody ever got past that, now they got to get past my British SAS commandos, my Delta Force, and my Navy SEALs. Do you think that's going to happen? And now they're here. I am here. My username is Mike. My password is Cindy the cat. It obviously isn't. And I'm here. Does anybody think that username and password was that meaningful? No. So the point is the IAM is going to be our last line of defense. And of course, we don't give people more privilege than they need to do or more rights to do their job. And what am I trying to do? Let's say Mark's trying to come to my super secret island. Before Mark comes to my island, he probably should call me and say, Mike, I'm coming. And I say, okay, Mark, I'll make sure to send a photo of which car are you coming in? Okay, what's your license tag? What time will you be arriving? And now I have people on the outside waiting for Mark. Now they would know to let him in or not let him in. That is a much better form of security, and that is still defense in depth than just assuming IAM works. Is everybody with me so far? Does everybody get those concepts? Because if so, Mark and I will put a security architecture together, and we'll explain each and what we did at each step. So I need to know that you know it. So if you know it, give me a hashtag AWS VPC security. And if you don't know it, or you need something, Mark and I can take a few minutes of questions before we get there, because I want to make sure everybody learns it.
Let's give them maybe 20, 30 seconds, Mike, and then what we'll do is
Yeah.
we'll take a couple of questions. I saw some questions there too that we might want to circle back before we get into the actual security architecture. But
Sure,
again,
I'm fine with that too.
All right. Okay, we're still seeing people come in with the AWS VPC security hashtag. Wonderful. And so this particular question, Mike, is going to be kind of like a three-parter. Okay, so I'm going to read it all. I think this is going to get our juices flowing here. So this is from Foolish to Crow to say, hello, can I please have some clarification on how the routing architecture within an autonomous system basically works? I know it uses IGPs, interior gateway protocols like OSPF. And could you tell me more about the architecture within? Tyrone, can you? Okay. And then it says, I'm also trying to understand, well, the role of internal BGP in relations to internal gateway protocols.
Okay.
Is it that many of the OSPF instances within the autonomous system, does it also use OSPF to speak to other OSPF instances within? What am I failing to understand when it comes to segmentation? So, Tyrone, you want to put on the first part of the question? Okay. So go ahead, Mike, and then I'll add to it.
So let's do this. So the first thing we need to understand is I'm going to draw a little map of a basic network, and I want to show you what we're actually talking about and why. So, and then Mark and I, because we can have fun with this, and it's a good question. So let's say we've got a network that looks like this. Inside of our network, we have a couple of routers. Let's just say 4. This is nothing, but we're going to make it look really easy. And let's say between each of these networks, we've got a couple of fiber optic cables. And we fully mesh these so every router has a connection to every router. While we're at it, let's put an ISP over here. Let's call it ISP A. And on the other side, we'll put ISP B. Okay, so in a traditional world, let's just say this is, we're going to use 65312. Just for argument's sake, 65313. And 65314. So in this environment, note we have 4 routers. And the interior gateway protocol OSPF will basically tell each router how to reach all the links in the network. So if I've got 1,000 subnets in my network, I need to know how to reach them. And that's the point of the interior gateway protocol. We're dealing with OSPF or ISIS in most cases. And the way these protocols work is as follows. Every one of these routers basically sends the status of all of its links and all of the subnets that it has. And they exchange something called link state advertisements. They build a table of the link state advertisements, and then they actually go and calculate the best path to go from point A to point B. So everything inside of your domain, and I actually think you picked up on something very good. Everything inside of your domain is inside your interior gateway protocol. Hold on, bear with me. So is inside of here. Now, the thing with OSPF is it has very indiscriminate on how it sends routes. So if this is all, say, in a similar area, because OSPF uses areas for segmentation, but if this is all in this, let's say this is the backbone area, every one of these routers has to know about every single link that exists in this network. So guess what? I add another router, and then I add another router and another router. They all have to have the same LSAs in their databases that all these do. Now, if those LSAs are already in your database, you don't have a lot of microsegmentation you can do to her. Got almost none. Now, we can create separate VLANs. And if we created separate VLANs and we had OSPF to route between them, we could still disable routing in between VLANs. We can microsegment on the VLAN itself. We can do things like a private VLAN on the VLAN itself. But we can't, those are things we could do at layer 2 where we could microsegment, which is where we would do it. And then at layer 3, we would just use an AS. Now, what is the point here? In our interior gateway protocol, we barely can filter any routes. We barely can filter routes. Now, when we connect to it with an exterior gateway protocol like BGP, we have complete control over the routes we take in. Complete control. So with BGP, we're designed for scalability. And what does the scalability mean? It means I may need to have 100, I may need to have 1 million routes in my routing table from 10 different companies or more. But if I need to maintain 1 million routes on my routing table, is it going to be fast? Is it going to calculate something on a dime? No, it's designed to be scalable, so it will be slower. OSPF, or interior gateway protocols that are used internally, are designed for speed. Between this router and this router, for example, it's got a hello and dead timer. The default is 10 seconds for a hello and 40 seconds for a dead, meaning if this router didn't receive a hello from this router, worst case scenario is by 40 seconds, it knows about it, and then it'll recalculate around it. It self-heals. BGP could be a lot slower. It could be minutes, but it will scale. So what's the point of this IBGP versus EBGP? Well, when we connect to 2 different internet service providers, let's assume we wanted to provide transit for the internet. So let's say we are also an ISP, but we are ISP-C. If we connect to ISP-B, if we choose to, and then we connect to ISP-A, if we choose to, if we take in A's routes into our system and then send them to B, and B's routes and send them to us, then ISP-A and B can talk to each other through us. We've just become something called the trans-autonomous system. Now, if we're an internet service provider, this is a great thing. If we're a business and you did this by accident and you took us down, this is a very bad thing. And I've seen lots of people make this mistake and take their company down. Their internet service providers could have protected them, but they didn't even know what to communicate with them. So there was that. So why would I have to run IBGP here? Well, we'll recall that this OSPF, these interior gateway protocols, are optimized for speed. And you'll recall that I said exterior gateway protocols like BGP are optimized for scale and for tuning. So if ISP-A has 1 million routes in its routing table, which it probably does if it's an ISP, and the ISP were to try to put those 1 million routes into OSPF, all these routers and the routing tables would crash because OSPF could never handle the 1 million routes, and all the entire network would die. So what you see in an internet service provider environment is they're running an interior gateway protocol so that the BGP speakers know how to reach each other. And then they're using IBGP to actually push the BGP routes across their autonomous system because their interior gateway protocol cannot actually handle the volume of the number of routes. Mark, if you want to touch that from a different perspective or talk about your perspective, think between you and me, we can make this simple.
Yeah, so that everybody understands what is the difference between using something like OSPF and then using IBGP also, as he mentioned. The protocols were designed for different use cases, number one. When we think about interior gateway routing protocol, Mike touched on the fact that it was designed for performance. Now, that is true to a certain extent. The other things that they really were designed for is to make sure that the connecting of the internal networks is done in a manner that, number one, is efficient for performance reasons. But also the other important point that we have with things such as OSPF, and for those Cisco fans out there that still like to use EIGRP, which I'm a proponent for it. It's not a bad routing protocol. I know me and Mike always go back and forwards on that. But really what you get there is, unlike BGP, and this is what many people don't understand, the interior gateway routing protocols, they are always looking to find the best and least expensive cost route. That is not something that BGP does by default. Why? Because BGP does not use a cost attribute or characteristic of the route to make those distinctions. So that's where we have interior gateway routing protocols. They were designed to find the best internal path to things. Sometimes you might hear verbiage such as hot potato routing and cold potato routing. Well, in this case, interior gateway routing protocols is what we would know as cold potato routing, basically meaning we're trying to find the best path to whatever exit that we're trying to get to. While hot potato routing is the opposite. We're basically just trying to say, what is my closest exit? I don't care if it's best. I just want it gone from me. So that is the difference there. Now, when it comes to IBGP, a lot of people look at IBGP and they only have this notion in it that we're going to be using it in an internal network because it scales better than OSPF, ERGRP, ISS. That is actually not true. The original use case actually for IBGP was for service providers. Now, service providers brought that on because we have this concept, what we call sometimes transit autonomous systems, which basically means that another service provider would become the man in the middle. So basically, traffic would come from one service provider, let's say service provider A, it will come to service provider B, but it's not intending to stop at service provider B. It's trying to get to service provider C. So what happened there was, if you were to take, let's say, external BGP routes, and you try to inject them now into your OSPF, ISS, EIGRP, whatever interior gateway routing protocol you're using, you're losing the characteristics that made up the route that originally was learned by BGP. How would you negate that? Well, you need a different type of protocol then, right? Or you just use the same protocol and you make a couple of tweaks on it so that you can actually just use BGP end-to-end and allow those characters or those attributes of that route to propagate through the system. That way that you're not stripping them, or you have to figure out how on the other end to actually reapply those characteristics or attributes to make the whole, secret sauce type of work. So that was the actual original idea of IBGP compared to EBGP, because we wanted to keep hold of those type of, I call them characteristics, but the official term is attributes. I like characteristics because it gives you an idea, right? Like a ear and different characteristics we have and features. So that's where you would use it predominantly. But remember, one is more built for scale, where you take a whole aggregate of the network. Basically, think about you have 1,000 networks, but you manage them. That would be an autonomous system. And you want to perform routing between your conglomerate of actual networks and somebody else's. But guess what? You don't know the details of the other network. That's where the IGPs come in. You send the route to the other person, service providers, and they take care of it for you. But that is the real distinction between interior gateway routing protocols specifically designed for interior purposes, while the other one is more like a makeshift to make sure that we can actually use the attributes that go through it. So that's my take on these. And by the way, just so everybody knows, there is no best protocol. There is no right or wrong. It depends on your business case. I want to say this first of all. Like Mike said, if you're looking to take in a full routing table, let's say even a partial routing table at this point, that is a public routing table, the IGPs are going to have a hard time handling 500,000 routes. And that's about a partial view that you would be taking in. It wouldn't work for you. That's where things such as BGP come into it, because of the way it handles the different updates coming in. And you don't always have to do these cold potato routing ideas. You can, but that's a whole different idea. And then there's other applications. I'm briefly going to touch on these because, again, this is not a BGP workshop. It's not even fundamental. But IBGP is also used when it comes to using MPLS and VPNs in conjunction to it. That's where we're using IBGP to actually as what we call a control plane, basically the brain that learns our routes, but we're also injecting additional tags to not only distinguish our local IP address or our local network, but we're also adding additional tags in it so that we can define what routing table eventually we're going to be injecting those routes. But we're doing that with MPLS, and we're doing this with IBGP, and we generally call this a layer 3 MPLS VPN. That's also where IBGP can be used. But there we're using it predominantly. Again, if you think about a service provider kind of environment, you might have thousands, if not tens of thousands of customers. So again, we're looking at what? Scale. We're trying to scale. And that's where BGP would come into it. And I'm going to regress here. Otherwise, it's going to turn into a whole BGP workshop again. So
I got to tell you, one year I traveled about... one year I traveled about 100,000 miles by talking about that RFC 2547, these BGP MPLS VPNs. Boy, that was a fun year. Got to meet a lot of people and got to speak to a lot of good networking geeks throughout the world. Really enjoyed that. Those were my geeky days. I loved it.
Yeah. Again, it just solves a different problem that people had. And if you're working on the enterprise side, you generally don't come across those problems because your network is not large enough. You're not feeding it. Now, if you maybe using universities, things like that, maybe you would use something like MPLS, but you would use it for different purposes. You would use it more for the idea of something that Mike was more used to, where we're now creating an environment where we have easier time of engineering or manipulating our traffic. We call this traffic engineering. So it's not something that we typically do in an enterprise network, even if we have 100, 200 routers. We wouldn't do that.
No, but if I'm designing a cloud provider's network, sure as bad I'm going to run something. I might have an MPLS switching backbone, and that way I can signal various tunnels and create faster rerouting. So it depends where we're dealing and how big the scale we're dealing with. Good point.
If we need point-to-point, multi-point, hub and spoke, if we need full mesh, partial mesh, etc. So,
exactly.
Very good question there. All right, let's take a look at our next question just here. And this is from Mohammed. And they're asking, can we be segmenting the VPCs and use third-party firewalls with Cloud WAN? The answer is yes. Right? So,
and Mohammed, that's exactly what you're going to do. If you connect two VPCs on AWS, you want to use a good firewall to do it. In between them, as well as other things like you would do from the IAM side, you would do filters in addition. But yes, definitely want to use a firewall in between VPCs if you're trying to micro-segment your network. Definitely.
And for everybody, if you come a little bit more like me from a traditional type of networking background, this is what we call service insertion, where basically what we're doing is in this case, we're taking the Cloud WAN construct. We're going to be using the internal segmentation that comes with that AWS service. But what we're telling the actual table within that construct is when you're going to make a decision, send this to the firewall, wherever the firewall is going to be, and let the firewall do its inspection. That's basically how service insertion works. All right. And Jose is asking, how do you secure VPC isolation and ephemeral resources against advanced persistent threats in a multi-cloud setup?
So, Jose, we talked a lot more about that in the beginning when we talked about our VPC pairing, and we talked about putting firewalls in between our VPCs and micro-segmenting what you put and that. So we talked a lot of that in the beginning of this. The key here is multi-cloud is no different than multi-data center. How do we secure multi-data center? How do we secure any place? We use firewalls. We limit the routing information, which we were talking about. We lock down the systems on both sides, whether that be hardening operating systems, host-based IDS, IPS systems, whether it be the firewalls you're using, the ACLs you're using, and the data center. Obviously, you've got more tools that you're using that you don't have here. It's using good SIEM systems to mine through your logs and detect things that are going on in real time. It's looking for data and data loss prevention systems that it's using. It's your identity and access management strategy and what you're doing and where your users are coming from and what their systems are, even to be able to access. It's the same cybersecurity that you would do off the cloud in the data center. What happened where it got bad is the cloud providers tried to make their own security services. Unfortunately, the homemade security services in most cases are nowhere close to what Cisco or Palo Alto or Fortinet or Checkpoint's coming from. And if you actually look at what the cloud is, it'll make sense to you. We had our traditional network and data center, physical server, virtual machine in the cloud, physical router in the data center, virtual router in the cloud, physical load balancer in the data center, virtual load balancer in the cloud. And because these devices were physical, they had greater features and they had greater functionality. They also typically have better performance when they're physical. So when we go to the cloud, we're trying to emulate or copy what we used to have in generic software, on generic processors, in generic hardware. So it's the virtual version of the old thing. Who has more time to focus on security? Palo Alto, whose whole world is security, or AWS, who's got 1.5 million people, and most of them are working in retail, and some of them are working in a cloud, and some of them are working in this business or this business. They don't. It's focus. It's the same reason, if you go camping, it might be nice to have a Swiss Army knife with you in case you need something. But if you need a knife, don't carry your Swiss Army knife, carry a knife. Something that you're going to grind a tree down onto, something you're going to start a fire with, something that you're going to chop wood with. Cloud providers are awesome. They are hosted networks and data centers, and they're great what they do. But the same way they're just adding the capacity, like a year ago, you could run IPsec on a direct connection, even though Cisco did it in 1998. The cloud providers are trying to catch up. And that's why we're showing you the tools that are native to the cloud providers, like the ACLs and security groups, which we talk about using. And then we keep pulling you off and talking about data loss prevention systems and SIEM systems and next generation firewalls and showing you how they work and talking about why you wouldn't architect a single content over node. I hope that makes sense. Mark, did you want to add to that?
Yeah, and so it's quite an expansive type of question that you asked. So it's nothing that we can answer in 2 to 3 minutes, but you're generally going to be using every tool at your disposal because it's between different cloud environments, right? So what I would suggest there is things such as segmentation. I love segmentation just because if it makes it a little bit harder for traffic or for an attacker or a threat actor to be able to jump across different networks that you may have. So that's always going to be key, especially if you're dealing with malware and things like that, because what you're trying to avoid is this lateral movement, right? This east to west type of movement when it comes to certain attacks. You're definitely always going to want to use encryption. Now, encryption at rest, meaning when it's stationary, you definitely want to be using that. But since we're talking about traffic leaving one environment and going to a different cloud environment, it's going to be encryption in transit that you're definitely going to be using. And then there's a slew of things that you want to implement as well when it comes to security from accessless, host-based firewalls, right? Whatever marketing jargon you want to throw on to whatever the cloud providers uses, you definitely want to do that. Something I do want to point out, though, and this is for everybody that might be wondering, like, why is this a big deal, what Jose is asking? It's a big deal because normally within your virtual cloud environments, the inter traffic or the inter VPC type of traffic, you want to call it, it's encrypted already. So you don't have to worry about it there, even though I would still suggest make sure that when it comes to segmentation, we just have Mike fly away.
I pushed the wrong button.
So you generally still want to have the same type of practices, right? But just remember that because it's within one environment, one cloud environment, but different VPCs, it is already encrypted. But from what I always tell people, from a design and implementation stage, you always want to have baselines and you always want to have best practices. So if you're going to do it for traffic that's going to be leaving one cloud environment, I would definitely also use the same type of security mechanism within the same cloud provider. That way that I'm not confusing, and believe me, this will happen, I'm not confusing my engineers on how they should be implementing and how they should be actually monitoring these things. And by the way, continuous monitoring is going to be another very effective, if not the most crucial aspect of making sure that you don't have any of these advanced persistent threats that are going to be there, especially the ones that are going to kind of lodge themselves into memory and then go from there and just execute maybe a code to be able to do certain things. So monitoring is going to be definitely crucial to be able to do this type of multi-cloud security. And there is, and pardon me if I don't remember, I think this was about a month or two ago, we did an entire bootcamp for about 2 weeks when it comes to cloud security, but a vendor agnostic bootcamp, the CCSP. I would definitely recommend take a look at that because that's going to dive a bit more deeper than what we can do right now into these type of aspects, touching on all types of different security mechanisms that you can implement to make this type of design work.
Yeah, that's what I would say, because we spent about 40 hours teaching that, Mark. It was 2 hours a day for 10 days. Now it's 20 hours. And then there was a book that we wrote that went with it. Because that question itself, honestly, could be a 20, 40, 60, even 150 hour answer. And that's why it takes me about 1,000 hours to train my architects to get them great and job ready. But I like the question. And if you go back to the CCSP stuff, which was free, it'll answer a lot of that.
Yeah, because you'll have to answer the question about a business case. What's my business case? Is the assets even important to secure? How much security do you need it? It's all type of different questions that you would have asked. But I hope, Jose, this gives you somewhat of an idea that all the different mechanisms at your disposal should be used when you're going to do something like a multi-cloud cross-site kind of traffic. All right, let's take a look at our next question. Let's do this question here, Mike, and then if you want to pivot back, we'll finish up with the architecture. Okay.
Sounds good.
So this is from John O. They're wondering, can a third-party next-generation firewall solution from a vendor like Microsoft's marketplace be integrated into an AWS environment in a multi-cloud setup? It depends, John, right? You want me to touch on it first, Mike, and then?
Well, yeah, sure. But and I know John real well. So let's say, John, in most cases, we're going to do exactly what you want. Meaning, we're not going to use that cloud provider as anything. We're going to go to the marketplace, the AWS marketplace, the Azure marketplace, the Google marketplace, and find the firewall or firewalls that best meet our needs and use a next generation firewall. So the answer is yes. Mark can tell you the other half of that, but yes.
Yeah, I was going to say it depends on what you're trying to accomplish. And
yes,
the most obvious piece, and that's why I said it depends, is whatever next generation firewall you use from the actual marketplace that Microsoft provides, you kind of need if possible, the matching on the other end. But if you don't have a matching firewall on the other end, let's say for some reason you have Palo Alto that you chose from the Microsoft marketplace, but you ended up going with something like Checkpoint on the other end. Then the question, and this is why I said it depends, is what are you trying to accomplish? You may just want to create a kind of like a VPN tunnel between them two so that you can tunnel your traffic. Yeah, sure. You can use Checkpoint, you can use Palo Alto. Mm-hmm. But if you're using anything that might be more specific to that firewall vendor, then you want to be matching the two firewalls. Because generally speaking, feature set is not always on parity between them. Like Checkpoint might have something that can accelerate some type of packets in the kernel level. Well, Palo Alto may not have the equivalent on that end, but they may do it rather on some type of what they might call like a WAN optimization or WAN acceleration on their side. So it's from a feature level, yes, they need to match. If you're just trying to connect the two cloud providers together, and you might want to do this with what we call a site-to-site type of VPN, if you want to go legacy term it, then it doesn't matter because that instance is going to be built in or baked in. The biggest thing there is going to be, can you match the encryption algorithms on both firewalls? Make sure that you have the same ones, and as well as the hashing algorithms, so that you can make sure that the IPsec tunnel will actually come up. Otherwise, if you have mismatching encryption keys and strengths, it's going to be a nightmare. It's not going to work that well for you.
Yeah.
A good question. All right, Mike, I tell you what, let's go ahead and let's finish up with the architecture, and then depending on time, we'll take a couple more questions.
Sure, sounds good. So let's put something together. Let's put some of these pieces together. And, there's a lot of environments we could be talking about from a security perspective. In this case, we're going to create a very simple web application. We're going to lock it down the way you could. And the modules that we will use here will apply to the rest of your organization as well. So let's say we've got a simple web application that needs to be reachable. Let's think about it from the perspective of the internet. So at the outside of my network, I'm going to put a content delivery network. And if you'll recall, when we were going through, planning against the DDoS attack, the content delivery network will offload my servers. We can also, on the content delivery network itself, use some DDoS protection. I don't care whose content delivery network you're using. It's got DDoS protection. Akamai's got their DDoS protection. Cloudflare's got their DDoS protection. What do you call it? AWS has Shield. Everybody's got DDoS protection for what we're dealing with. So we're going to put that at the edge of our network. Now, as soon as we connect to the internet, right behind it, we're going to need a firewall. Now, depending upon the firewall we choose, we're going to get different features and functionalities and have to deploy them differently. In most cases, you need to use more than one. And here's the reason why. Not always. For example, with AWS, you can get away with a Palo Alto. They've got a very nice, cool native situation. You don't need to. But I'm going to need to do this because in the data center, I can get a firewall and I can get a very high availability device itself. I don't have access to the same level of devices that run heartbeats between them and a cloud provider. I can't go to the cloud and rack and stack my firewall. So I'm usually going to use some flavor of a network load balancer. And then I'm going to go to my marketplace on AWS, Azure, Google. I don't care. It really doesn't matter. And I'm going to get a next generation firewall. And the reason I'm going to get a next generation firewall is it does everything that we showed you before, like an AWS WAF. And in addition to the AWS WAF, it's going to block threats that it doesn't know about. So we've done this. Now, we've got a lot of things. Any of you guys or gals ever watch MMA, martial arts? Any of you like to watch martial arts? Okay, so I've got a lot of good Muay Thai skills from my youth. That's what I studied. I studied Filipino martial arts. Guess what? So my skills as a striker from my Muay Thai were really good. But where I train, people don't go to the ground and they don't fight on the ground. They're trying to get up as fast as they can from the ground. What happens if you get a Muay Thai fighter that gets kicked to the ground by a jiu-jitsu person? Uh-oh. Now they're on the ground. It's a pretty dangerous place to be. Now, what if I told you in security, when it comes to firewalls, not all firewalls are created equal? Some firewalls do some things better than other things. Some firewalls, artificial intelligence will catch an anomaly that another firewall might miss. And another firewall might catch an anomaly that another firewall wouldn't miss. So if it really matters, I often use two sets of firewalls from two sets of vendors. I pop the same policy on them, but Palo Alto may catch something that Checkpoint doesn't do, or better, Checkpoint's going to catch something that was missed by Palo Alto and Fortinet. We don't know, but so we're going to use multiple levels. So if we go back to this situation and we used another set of next generation firewalls from another vendor, now if the first vendor's firewalls don't work, maybe somebody else's will. I'm going to add some things. Now, if we think about it, if we really wanted to get a lot more information what's going on to really be able to see something, couldn't I put a IDS IPS system in there behind the firewalls? Now, the reality is these firewalls will give us some of this features and functionality being next generation firewalls, but wouldn't another device be better? And these next generation firewalls send logs. These next generation firewalls send logs. These load balancers send logs. And in many cases, we can even put security groups and other cool stuff on these load balancers. So we're going to get all these logs for these systems. Now, we're going to be sending all these logs. And quite frankly, I would put my website in one VPC and I'd put our corporate other stuff in another VPC and then do VPC pairing between them. But let's say for right now, or for argument's sake, we're going to put our logs from all these devices into the same systems. All the logs are going to go there. Now we've reached a point where we need our web servers, right? So typically speaking, we're going to have some form of a load balancer in front of our servers. If I've got big 128 core AMD EPYC servers, I'm going to use a network load balancer. I got little mini servers, I'm going to use an application load balancer. It doesn't even matter. So I'm just going to put a load balancer here. Now, what does this mean? It means this device over here will definitely need a public IP address. And behind this, I'm going to have virtual machines. These are going to be my web servers. And of course, if I'm going to speak to, if I have any app servers or something behind it, again, I'm going to have another load balancer. I'm going to have app servers. So while I'm at it, I'll just put some app. We're just going to put some servers here just to make it, because we don't have a lot of space. Now let's look, we've got this. So our content delivery network, we lock down these load balancers with security groups. Then we've got our firewalls. You know, now at this point, what kind of traffic needs to go to these web servers in today's world? HTTPS, right? So the only traffic that's ever going to be allowed by this firewalls is HTTPS. These firewalls is HTTPS. This IDS IPS system is just going to be watching passively. Now this load balancer itself, it has a public IP address on it. Can I put a security group on this load balancer to protect it? Yeah, it comes with it. Now my virtual machines themselves, can I put a security group in front of them to keep bad traffic from coming in? I absolutely am most definitely going to. Now the virtual machines themselves, I have to harden those operating systems, right? That means taking the operating system, having the security team put the latest patches on it, removing any unnecessary services, closing any ports that you would find, open ports that could be used to connect to the system. Now I've got to put some endpoint protection on my virtual machines, host-based firewall, host-based IDS, IPS systems, malware kind of thing. Now, do my virtual machines have any storage? You typically have block storage, right? So what do I need to do to my block storage? I got to encrypt it, right? Now, at this point, all my data going back and forth is actually encrypted. And we've done a lot of work here, and we've done a lot of work here, and we've done some other work here. Now we've got people that want to actually connect to these systems. At some point, we've got a user, right? The traffic's good. The conforming traffic that went to the web server, was clear. It made it through our content delivery networks, wasn't dropped, made it through our next generation firewalls. All we're good to go. IDS IPS systems not looking for something. Security group on the load balancer protected stuff from coming in. Security group protected bad stuff from going into the web VMs. The web VMs were locked down by their host-based IDS IPS systems, anti-malware stuff, and of course, even their storage is encrypted. And of course, we would do the same thing for anything else. Now, of course, we would have an ACL, which servers could talk to which between, say, web servers and any of these other servers. Now, when somebody wants to log in, they're going to log in. They're going to hit our corporate directory services, which is most likely going to be Microsoft Active Directory or something else, which will be federated back into our environment. So we're monitoring our logging over here. We've got something. Now, we probably should have some flavor of a data loss prevention system, too, that's sort of monitoring and making sure the wrong stuff isn't leaving our systems. So we've got some type of DLP system. Now, understand that in reality, this could be by the cloud provider or someone else. These next generation firewalls will be coming from a marketplace. These next generation firewalls be coming from a marketplace. These IDS IPS systems are going to be coming from the marketplace. This security group on this IP address, cloud native. Security group protecting these things, cloud native. ACLs from server to server, cloud native. Host-based IDS IPS systems, all that stuff on the device itself, third party like a Trend Micro or a Broadcom Semantic kind of thing. Data loss prevention systems, no, they're not going to be coming from the cloud provider. Your IAM is going to be federated into something bigger, and your SIEM systems, again, are going to be from a company like Splunk. This is literally what it takes. Now, we can get even better and think about this. If these web servers themselves are actually in an auto-scaling group, and they get hit with too much traffic, they can scale out and add capacity. And any one of these devices along the way could find stuff. Now, here's the beauty of this. Let's just change this real quick. Let me pop in a new slide so you can look at it. So if I have this exactly on AWS and Azure, now what's going to change? Let's say this is Akamai on Azure, and let's say this is CloudFront on AWS. Now, Azure will call this a network. Azure will call it an Azure load balancer. AWS will call it an elastic load balancer. Now, of course, the next generation firewalls are going to sit on virtual machines, which in AWS are called EC2 instances. In Azure, they're called Azure virtual machines. In Google, they're called compute engine instances. Identical setup so far. Now, the name of this security group versus network security group on the load balancer, that may change. With the block storage that sits on the web server, maybe it's called managed disks in one cloud versus elastic block storage in another, but it's the same thing. Same data loss prevention system, same IAM system, same SIEM systems. So I can do this in AWS and Azure. And if I wanted to do this for, let's say, high availability, it's pretty simple. I put 50% in AWS. I put 50% in Azure or any other cloud I wanted. Nothing to think about. The identical demilitarized zones on both sides, the identically configured servers on both sides, the identically configured systems that all spew to the same systems, and all I need over here is a DNS policy. Let's say I do a weighted routing, so weighted DNS. I do 50/50 weighted DNS. Since I have no idea why people think multi-cloud is hard, since we've done this stuff for decades. So here we do. 50% of the traffic goes to AWS, 50% of the traffic goes to Azure. DNS does a health check. AWS, you there? Yeah, great, I'm here. Azure, you there? I'm here. Traffic goes back and forth, back and forth, back and forth. Then one day, DNS does a health check. Azure, are you there? Gets no response, but AWS is still there. Azure, you there? No response. AWS, I'm still here. Azure, are you there? No response. DNS sees Azure as dead, sends all traffic to AWS, and it auto scales out because your stuff is in an auto scaling group. And in about 20 to 40 minutes, you're up completely on another cloud, completely unaffected by the outage. And guess what? If you've got 1,000 servers, it doesn't cost a lot more to put 500 in one cloud and 500 in the other cloud. And by making sure that any cloud communications are where we're limiting our routes, we're filtering with ACLs, we're filtering with firewalls, we're making sure that we're immune to a cloud provider's failure or a cloud provider system's failure. So that's kind of what it's going to take to put an overall security architecture for your web VPC using some of the features and functionalities we talked about today. Those common to your VPCs, VNets, Google, because it's all the same.
Yep. All right. Did you want to finish up with taking just a couple more questions that we have left? And then we'll see everybody tomorrow when it comes to some career questions. All right, Daron, let's bring up, I believe we stopped at Jose's question, if you want to bring it up. All right, Jose. Well, he's got some good questions today. All right, so he's asking, how do you ensure consistent VPC security policies and threat detections across multiple cloud providers while minimizing latency and misconfiguration? All right, Mike, if you don't mind, let me just briefly touch on the minimizing the latency and misconfiguration, and then we'll kind of track back a little bit when it comes to the whole policy.
Sounds good.
So, Jose, when we're talking about the idea of latency and misconfiguration, with latency, it's really just distance. So if you want to minimize latency, and let's say, I mean, we don't have to say it, it's the fact all these cloud providers are going to use fiber, right? So we already have light instead of electrical, so that's going to be faster. That's the most optimal. But we want to minimize the distance between whatever services we are offering either to ourselves or the customer that we're serving. So things such like edge locations or point of presence, wherever we can bring the data closer to, that's really what's going to work there. And then there's some additional concepts what already Mike discussed in regards to content delivery networks, right? Those we can also use, depending on, of course, where they're located, on delivering the traffic or the services closer to ourselves or our customers. When it comes to misconfiguration, this is a little bit of toss-up for me, because the first thought that I get here is that you want to use some type of automation. Because generally speaking, with automation systems, like think of it something like infrastructure as codes. Generally speaking, what they try to do is they try to standardize the actual configuration that you have, but they also check to make sure that the configuration is actually sound. A lot of the modern software-defined networking solutions, they do the same thing. They have a checker that kind of parses through the code to make sure that the configuration is correct. But this has to do with automation. Now, depending on how adept the organization and the engineers you have are there with automation, this could be a little bit of a toss-up. But generally speaking, automation, and when it comes to cloud providers, all of them are going to support infrastructure as a code anyway. So you can use one of the tools, could be Terraform, generally speaking, something that can take a look at the code itself. When it comes to security policies, here's the little tricky part. You mentioned across multiple clouds. So what that immediately tells myself and Mike is we have to throw whatever proprietary services that any of the cloud providers have out the window, because we can't use them across multiple clouds. It just won't work. So something there I would suggest, and it kind of goes into this whole idea of what you also mentioned with threat detection, is you want to look for a SASE type solution, basically a security cloud delivered solution. And it's supposed to include things such as centralized security management. That's going to be important. And also what you want to look there for is the ability that you can actually pick them out of the different marketplaces. So this is where you want to go again with something like a Palo Alto. You want to go with like a Checkpoint. Cisco has also pretty good solution that you can tie into their software-defined networking design as well that they have, and Palo Alto and Checkpoint does that as well. I'm forgetting the other firewall vendor now. FortiGate. There you go. FortiGate. I don't want to leave them out before I get hate mail from FortiGate telling me, Mark, why did you not mention us? But FortiGate, same things. You can have managers, right? Security managers, central security managers that can manage all these different firewalls. All of them have some kind of SDN component to it. But the important part is they also have the SASE component to it, where you can now tie in all those different cloud vendors together and have them kind of take a look at it. The little tricky part here is going to be the SIEM system. But if you can find a SIEM system, and I know this touched a little bit more on the question that Aman kind of posted in there, but if you, and then you do want to tie it back into your SIEM system, but you have to pick the right SIEM system, either Splunk or maybe something like, I think IBM has one. See if
They
I
do
remember the
Curator.
name.
I think it's Curator.
Curator. There you go. Thank you. Curator. So something like Curator that you can funnel all the traffic in, that's definitely going to help you work on that. And aside from that, I'm trying to think. Anything I might have left out, Mike, that you can think of?
Yeah, I would say, I mean, because Mark hit on all the pieces, the automation, the common threads, but we can't just focus cloud, because they're going to have a data center too. And if you're counting that as cloud, good. But they're all companies are going to have a lot of stuff that we need to think about. They're going to have these IoT sensors that we need to think about, and they're going to be a bigger challenge. They're going to have specific applications and industrial control systems. So we need to think security. And when we start thinking of the security policy, which the architect is going to be focused on, they're going to be focused on the policy that is more focused on the executive needs of the business, how that business needs to protect itself from various pieces of harm. And it's going to be a very high level policy. And that policy will be, how do you do this? How do you do this? In an incident, who does this? In this, who does this? And it's going to be pretty large. So, you know, that's where we're at that architecture level. We're also looking at the technology, but at some point it's going to have to go back to the engineers and say, how do you do this? How do you harden this operating system? Here's what we want. How do you go do that? Because from policy and architecture, it's all about the planning and the blueprints. But at some point, there's some people behind the scenes, those engineers that we love so much, they're going to have to build this and turn it into reality.
Yeah. Think of them as they're the people that are going to make you look great in front of your bosses. And they want to look great in front of you because you're going to be their boss. So in that essence, very important to keep up that relationship. And believe it or not, we need more engineers. I know we don't necessarily, let's say, per se, train that idea of engineering, but we do need more engineers, just like we need more architects. We need that combination of people to be together to make anything. Doesn't matter if it's networking, application security, success at the actual organizations. Let us go ahead.
And I'm going to touch that engineering. We need better engineers. So at an architect level, it's all human to human, person to person relationship development. It can't be replaced by AI. At the engineering level, that technician level work, how do I click at the management console? How do I write a basic bash shell script? How do I write a Python script? AI can do that. What we need, and it's incredibly hard to find, is we need those engineers that understand the technology, that understand how that technology works and how it fits together, how to performance tune that technology, how the technology is going to break, how a break in one part of the system affects another part of the system. Those engineers are hard to find. 50x certified people, configuration gurus that don't know what they're configuring. That's the concern. Those are those that are getting laid off and replaced by AI. The really good engineers that Mark are talking about, the people that can look at it and say, okay, I got to lock this down. Those little wizards that get behind their computers, and there are those wizards. We need many more of them. So when we talk shortages, there's a massive shortage of architects because you can never find all those skills in the same person. There's still a massive shortage of qualified engineers. There's a lot of surplus engineers, but shortage of qualified engineers is grossly severe too.
Good point.
But the qualified people are, and there's a difference. If Mark was my network engineer, I don't care that he can go to the Cisco router, type config t, interface gigabit 0/0, IP address no shut, and then put on a routing protocol. I don't need to hire that. I can do that with AI. Give me a script. What I need Mark to do is to say, okay, so we've got 5,000 remote locations. Where are you going to constrain your link state advertisements? So what are you going to do with these external routes? How are we going to make sure our route recalculations aren't too much that it overwhelms the resources on the router? What is the limit that I can handle on this table, and how do I work around that limit? How do I aggregate? How do I route? How do I summarize? That's what I need in an engineer. And that means the people need to know how the technology works much more than they just need to know how to configure that. The configuring is easy. It's the knowing what and why that's near impossible to find.
Yep, definitely. So tuning the system overall, that's the crucial part. All right, let's go on to our next question here before we wrap up today. And this is from Aman. They're wondering, can you touch on cybersecurity about vendors out of the cloud? Let's say database services by MongoDB or log analytics by Splunk. How would you securely connect these vendors? Aman, I'm going to take the example that you gave here, right? You mentioned MongoDB and log analytics by Splunk. And I'm gonna say fair warning. I'm not afraid to even say this live on YouTube. I am not a database wizard. Okay, so I don't configure databases. I just know when they're needed and why they're needed. But when we're talking about connecting these services together, most of the database services and then any of the security information event management systems, such as Splunk, being a SIEM, and Splunk is actually also what we call a SOAR and an XDR, which is just an extension of a SIEM system to allow us to be able to actually respond with some automation as well built baked into it. But when I look at all of these, I'm thinking about role-based access control. That's the first thing I'm thinking. Why? Because I know for a fact that MongoDB will have that functionality built in to define roles, and so will Splunk. So I can marry those two. Now, depending on if I have access, let's say, to some type of Active Directory service, or let's say like an LDAP service that I can use for these role-based access, I may have to kind of finagle a little bit with that to see that I can match them on both ends, but that would be one of them. Splunk, as well as MongoDB, and if I'm incorrect, somebody correct me on this, please. But they both actually support encryption. So that's what I would use. I would encrypt my databases and I would encrypt my connection. Now, the connection encryption, I would generally do very easily. These systems are not going to be right next to each other. So I'm going to use transport layer security, basically TLS. The same thing that we use when we connect to any type of web page out there. That's predominantly what I would use. And then let's say, because you mentioned security, and Mike just did the security architecture. Let's talk defense in depth, right? So what I would do is I will put a firewall in front of that too, in front of both systems. That way then I'm adding some type of restriction into what connections come in and out of those different systems. But your friend is going to be the encryption that's baked into the various applications that you have. You definitely want to take advantage of the encryption mechanism from TLS as well. And you also want to take advantage of any type of, if you want to call it identity access management systems, but basically role-based access control, where you can define it and then couple that back into an identity access management system, maybe using something like Active Directory or using LDAP for those type of protocols to provide services. I hope that kind of answers your question. I know it was a little wide, but I wanted to give you a little bit more of a vendor agnostic type of idea of how we can do that, because generally speaking, encryption and some type of user database with authentication of the databases of the users is commonplace. So, and then of course using transport layer security. I mean, you can't do nothing on the internet these days without TLS unless you're just going to go unencrypted. And if you go unencrypted, I'm really going to wonder why that is. Why you're being such a brave person to go unencrypted up on the internet. So I'm trying to think outside of that though. But business aside, I can't think at the top of my head if there might be anything else that is baked into these databases. So
yeah, there are things that can be done on a database. There are IAM permission things on a database, and each database itself will have best practices and vulnerabilities. But this is one of those things where, security engineer, read the best practices by the vendor on how they tell you how to lock down their database, because they'll have their own best practices. And that's what we really got to look at it. So let's say Mark and I are talking BGP. The BGP that Mark and I know is great on a Cisco router, a Juniper router, and a Arista router. It doesn't matter. It's going to work on all of them. But I'll tell you what, I promise you there's some vulnerability that Mark or I wouldn't know about because they wouldn't publish it. It's going to exist on everybody else's stuff. And when you talk to the provider themselves, don't do that. Why shouldn't I do that? It's in your design guide. Don't do that. Well, why shouldn't I do that? Well, we're having a problem with certain customers that are having this, so just don't do that. Oh, okay. So sometimes they know of a weakness in their system that they're trying to tell you about that you shouldn't do. So at the end of the day, You basically have to design the right architecture for the business, but you also have to ask the providers. And it's the same way, like if you're going to buy a firewall and on this thing, 10 gig stateful throughput on the firewall, you look at it and say, this is great. And then you say, let me test it. And then you have somebody take an IXI or a traffic generator. And then you find that when you turn all the services on the firewall, instead of getting 10 gigabit a second, you get 100 megabit a second. And then the thing is completely used. So yes, you might get this much, but under which circumstances? So that's why we always have to ask the provider. And that's why we usually have a QA team actually test it, because what you should get and what you actually do get, not always the same thing based upon your usage patterns and traffic.
Yeah, and I know this is not necessarily part of this, but it just reminded me is whenever you're researching and evaluating different type of solutions, and this comes even with vendor solutions, as Mike already said, be wary of the claims. Make sure you read the fine print. Make sure you have a list of good questions, probing questions to ask them. And under no circumstances, believe any, and I mean this, especially blind, any third-party testing. And the reason I say that is there could be fine print on those third-party testing that might say that they tested a system, and let's say the system scored great. And then you find out that the way that the test was actually designed was to shine light on a particular feature set or particular performance enhancing feature that particular product has that maybe the other product was not able to necessarily reach at the same type of level. So again, you always want to be very careful reading the fine print, ask questions. A lot of these vendors will have their own sales team on there that will have either engineering or architecture background that you should be asking these probing questions as well. So, but in either case, Aman, I hope that give you a little bit of an idea of more of the vendor agnostic things that you can do. But definitely always read the fine print, ask the questions, and there's going to be a plethora of other things that you can definitely do that that's not coming to my mind now to lock these things down.
Yeah.
Go ahead, please.
And, the key is, let's assume we're a cloud architect or a security architect or an enterprise architect. The whole reason we want to interact with our customers and their solutions architect is for them to do research for us. We're not necessarily looking for a vendor to tell us how to design our systems. We want to design our systems to make them work for our business needs, not what they want to push. But, AWS will know the performance limitations of a load balancer better. They're going to know where their things are going to break than what they're going to publish in their marketing numbers. They're going to know where their constraints are. So you're going to want to bring in an AWS, an Azure, a Google, a Cisco, a Palo Alto, a Fortinet, a Checkpoint. You're going to be dealing with all these vendors. And that's why half of the architect's job is vendor management. Because now you're going to have to figure out not only what you need and what's the right strategy. Now you got to figure out which vendors you're going to actually deal with. Which ones, after you evaluate all trade-offs, are going to give you the best solution for your needs, which are going to be completely different for somebody else's needs, which is why there's never a best tech. Great questions.
All right, let's take our last question here. We'll round it up from John O. They're wondering, is identifying a single point of failure in a client's architecture an effective strategy for selling technology while delivering value to the client?
Okay, so John, I can tell you, anybody that's got an internet business, here's what they get all day long. Your videos need better editing. Your videos need better search engine optimization. You need better graphics. We don't like your web server. You need this, you need this, you need this. So generally speaking, when someone comes to me and says, you got a problem, I say, and I don't know who they are. And I'm like, okay, goodbye, 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 goodbye. Now, what do I care? How do you sell a product? And then how do I answer this, John? And if you're the John I think you are, you're going to understand this. So, John, the first thing I need to think about is, if you give me this water bottle. Now, right now in my house, this body armor, my wife buys it at the store. It's $1.50 each. And I'm willing to pay $1.50 for it. Now, all of a sudden, I am out on the ocean. Somehow my boat sinks to the ground and I am in a life raft. And somehow I've got my wallet on me and I am 20 miles from the shore and someone says, I'll give you this water bottle for $10,000. I say, I'll buy it. And the reason is if I don't get that bottle of water, I'm going to die. And I don't care what they charge me for this bottle of water, it holds more value to me than the bottle of water when I'm in my house and I can just fill it up out of the sink. So the only way to really sell a technology to a business is to evaluate the business, look at that business's pain points, look at that business's challenges, and then show why your solution is going to mitigate those challenges and help them. Now, John, if you look at a client's architecture and they're a bank and a minute of downtime costs $1 million per minute, and then you were to approach that bank and say, I've identified this single point of failure, the expected risk that you're facing from this single point of failure equals this many millions of dollars per year, and you can mitigate this risk for this, and see, it's a lot cheaper to mitigate the risk than it is to deal with it, to have it, well, then yeah, you're going to win. So if you can look at the performance standards, if you can quantify that organization's downtime, yeah, you can win on it. But you're not going to just go in there and say, here, your architecture's bad, you got a problem. And there's a couple of reasons why. One is people buy on outcomes versus what they have. Two is the chief information officer and the cloud architects and the network architects that made the bad design, which is what you're going to see in 80% of the cases. 80% will be bad designs, 80% cloud failures are what we're dealing with, between 7 and 80%. You're going to have egos that are going to be unhappy. And, you know, if you walk into that chief information officers and you made this mistake, yeah, I don't know. And I know you, John, I know you're going to do that. But, you know, you're meeting with a new client, you're talking to them, you know, I noticed this. Here's a question for you. What's your cost of downtime? How much downtime did you have last year? What was the impact of that on your business? When you had downtime, which systems went down? What did that actually cost you in terms of revenue? What did that cost you in terms of any potential customer losses that went somewhere else? How did that impact your business? How did that impact your brand? And you get some, oh, it was bad. This happened, this happened, this happened. And you can quantify that. Okay, well, here's your single point of failure. Last year, you had $25 million of outages, and all we got to do is spend $1 million to fix it. No big deal. So I'd focus it more on the outcomes of what you're looking for, John. John, I have a feeling you're from Nigeria, living it over there in England. And if you're who I think you are, it's always good to see you.
And before we wrap it up, I'll add this for John here is identifying anything does not mean you can sell it.
Yes.
When we're talking about a customer, we generally, when we go through this phase where we're talking to them and we're trying to identify, as Mike said, what are their pain points, and as well as what are their pleasure points, because you don't want to be all negative. You generally want to be able to draw out eventually that the single point of failure is a problem for them. Otherwise, you're not going to be able to do that in your initial type of discovery call. You'll have to do it down the line and be able to actually speak to an individual for whom that might be a problem. Because here's the thing that many people don't understand. When you have a conversation with the client, it's not going to be the only meeting that you'll ever have. No. Additionally, the person that you might be speaking to may not be necessarily a decision maker, may not be in control of the budget. They may be in control of a particular department that has a particular need. But what about the other departments? So you might be just talking to that person, let's say, that is in charge of software development, and their department has been complaining about performance of the network. That person most likely will never, ever mention a single point of failure to you. But as you start maybe talking to executives, maybe somebody who's in charge of the budget, somebody who is aware of what Mike mentioned, what it costs when it comes to downtime, then you might be able to find out and draw out of them that, hey, X, Y, and Z has cost us this much money. And because of that, we're looking at your particular solution as a way of mitigating that particular problem. But again, it's not the identifying aspect that makes you sell it. It's the actual idea of, can you tie it back to a business case so that they understand it? Can you tie it to some type of measurement? We generally talk qualitative or quantitative kind of measurement. So in this case, you want to tie it to numbers, right? Money, so that they understand what is it costing them? What could we save when we can mitigate these things, right? In these aspects, we are actually trying to appeal to the logical aspects of the company. But then we also have to create, and hopefully through our conversations with them, we create a need and a desire, right? We're trying to appeal now to the emotional side of them, these feeling sides. We need to be able to marry the logical and the emotional part of it. And when you can bring that together and then present it in a manner that is going to be appealing to all the variety of people that you will be speaking to, then you will be able to sell your architecture. But only at that point. The identifying part, that's not going to sell anything, John. Just a little heads up. But aside from that, that was a fun question to kind of wrap it up. That goes like in a bread and butter that Mike and I like to talk about it. But again, tomorrow we'll have the Q&A that we do we'll try to do every week. Sometimes there might be some holidays or something that we'll have to postpone it. But there you can ask similar questions just like John asked in regards to how would we go about identifying things, or what is necessary in selling a particular piece of an architecture or the entire architecture, or maybe just what are the steps to be able to get towards a role, such as that we discuss more in detail on Thursday's webinar on how to get your first cloud architect job. And we go into the different types of architect roles, what is necessary from a skill set level, both our hard skills when we're talking about our technology skills, as well as our soft skills, where we're talking about our communication, and just as we touched on with John, our presentations and our sales skills as well, and business acumen. And then again, when we talk about this emotional intelligence, right, being able to appeal and be aware of how people feel and how we can make them be included. So there's a lot of fun that we're going to have tomorrow. There's a lot more that's coming this week, every day. What we invite you and make sure that you tune in to every session that we have. Make sure and let's see if I can get this YouTube link down, Mike. I think I can, right? Like the video if you liked it. Make sure you subscribe to the channel for more videos and live sessions. And then I believe, since YouTube can never decide on when and how they want to notify you, still make sure that you hit that notification bell, at least that way that it lets you know that we're live or a new video has been posted. You're very welcome, John. I hope that worked. We're very grateful that you all were here today. I hope you enjoyed the session. Again, it's a plethora of technologies and solutions that we talked about it. Sometimes we can't go in depth as we would like to, but we still try to give you some value for that and answer your questions surrounding to see how we can still tie in security into something as a isolated instance, such as a virtual private cloud instance, your virtual private data center. Any closing statements, Mike? Anything that I've forgotten?
Yeah, I had fun spending the day with all of you this afternoon. Mark actually, he's helping me learn the lingo of like, comment, subscribe, that kind of thing, because we're both learning YouTube. We're both network architects and enterprise architects and other things that we're used to it. So we're doing that. So if you had a good time, hit the like button. It signals the algorithm to send more people our way, and we love training people. So hope to see you tomorrow on the career question and answer session, Thursday's morning webinar on how to be an architect, and it's on Zoom. So bring any career questions you want. We just want to help you. Take care, everyone, and hope to see you soon.
Goodbye, all.
Bye, everyone.